billions of light years away, in the quiet dark of the Virgo cluster, something stirs, older, larger, and more powerful than almost any other thing in the universe. This is Messier 87, a titanic galaxy whose core hides a secret so massive it bends reality itself. For billions of years, it has devoured stars, warped time, and reshaped the space around it. And yet, from across the cosmic gulf, we can still feel its pull. Tonight, we'll journey to the heart of this monster, to the black hole 6.5 billion times the mass of our Sun, and witness how its gravity stretches the very fabric of existence. How vast can a galaxy truly be? Can its reach extend beyond light, beyond time itself? And what does it mean for us, here on this fragile world, to be part of such an impossible scale? Before we begin, if you enjoy this type of cosmic journey, take a moment to like and subscribe for more voyages into the unknown, and share your thoughts below. Settle in and let's cross the intergalactic dark and uncover the true enormity of Messier 87. Let's begin. In the constellation Virgo, 53 million light-years away, lies Messier 87, a faint oval in the sky that hides unimaginable power. Its hazy glow marks the center of a colossal cluster of galaxies, each orbiting this silent monarch. If you were to look toward Virgo on a calm spring night, through the still air and the soft hum of Earth's rotation, your eyes would find nothing more than a blur. A soft patch of light, almost indistinguishable from the background stars. But behind that blur is an entire kingdom of suns, a galaxy so vast that its gravity shapes the destinies of thousands of worlds around it. Astronomers call it Messier 87, or simply M87, and in its stillness hides the power of creation and destruction itself. Through a telescope, its light is calm, diffuse, and ancient. But when instruments sensitive to radio, X-ray, and gamma light are turned toward it, a very different image appears. Energy streams outward from its core, vast bubbles of radiation spreading through the void. It is a sleeping dragon breathing quietly into the dark, and each breath ripples through the fabric of its surrounding cluster. M87 is one of the largest elliptical galaxies known to humankind. Its structure defies the elegance of spiral arms or the symmetry of barred galaxies. Instead, it is a sphere of chaos, an immense glowing cloud of stars without direction or pattern. Its boundaries are unclear, fading gradually into the background of the Virgo cluster. Even the concept of edge seems to lose meaning here. M87 simply exists, immense and untamed, its gravity drawing in anything that drifts too close. To understand its scale, imagine this. Our Milky Way stretches about 100,000 light-years across. M87 is at least 5 times wider and hundreds of times more massive. It contains not hundreds of billions of stars, but trillions. Around it swarm galaxies like fireflies, caught in its invisible current. The Virgo cluster itself, a congregation of more than 2,000 galaxies, seems to pivot gently around this one. At the heart of this colossus is something even more extraordinary. A black hole with the mass of 6.5 billion suns. It is so large that the orbit of Pluto could fit comfortably within its shadow many times over. Its gravity is the silent hand guiding everything around it, from the slow dance of stars to the 1,000 light-year jets that carve through the vacuum. But M87 is not merely a monster. It is also a record of time. The stars within it are ancient, their light beginning its journey long before Earth even existed. Many of those stars have already died, their remnants drifting as white dwarfs and neutron stars. Others burn faintly in shades of red and gold, aging suns suspended in a galaxy that has outlived countless generations of cosmic evolution. If you could stand near M87, if you could somehow look up from within its luminous haze, the night sky would never be dark. Every direction would hold thousands of suns. You would see galaxies as distant smudges, orbiting faintly in the background, each one a tiny spark in the gravitational ocean of the Virgo cluster. And as you watched, you might feel a quiet truth settle in, that what seems faint and fragile from Earth is, in reality, immense beyond comprehension, that the softest light in the night sky can hide the weight of a universe. Messier 87, the giant in Virgo, reminds us that power does not always roar. Sometimes it hums softly in the darkness, waiting for those who know how to listen. When Charles Messier catalogued this faint smudge in 1781, he had no idea he had uncovered one of the largest galaxies in the known universe. Through his small telescope, M87 appeared calm, but behind that calm shimmered chaos. Messier's telescope was modest by today's standards, a narrow brass tube, perhaps no longer than his arm, mounted on a wooden stand. It showed him the heavens in soft shades of grey, every star a tiny flicker in a sea of shadow. That night, while searching for wandering comets, he stumbled upon a glow that refused to move. It was not a comet at all, but something far more ancient, a galaxy so immense that light itself seemed trapped within its silence. He noted it down as Nebula 87, unaware that he had marked one of the greatest cosmic powerhouses ever found. To Messier, it was simply another obstacle in his quest to track comets. But history would prove that this smudge, faint, patient, unremarkable, was no obstacle at all. It was a beacon. For nearly 2 centuries after its discovery, M87 remained mysterious. Astronomers peering through larger telescopes saw it only as a hazy sphere, brighter toward the center. It lacked the swirling arms of spirals or the dust lanes of barred galaxies. To many, it seemed almost unfinished, a formless, glowing wound in the sky. It wasn't until the dawn of the 20th century that its true nature began to emerge. In 1918, American astronomer Heber Curtis pointed one of the world's largest telescopes at M87 and saw something that no one had seen before. A slender, brilliant streak extended from its core, as if the galaxy were firing a beam of light into the void. It wasn't a photographic flaw, nor an optical illusion. It was a jet of energy, plasma hurled outward at nearly the speed of light, a visible scar written across 5,000 light-years of space. Curtis didn't know it then, but he had just glimpsed the heart of a supermassive black hole at work, though the concept of such an object didn't yet exist. Astronomers had no language for what he saw. The term black hole would not be coined for another half-century, but M87 was already whispering its secrets, long before science had the tools to listen. Through the decades that followed, each new instrument peeled back another layer. The Mount Wilson Observatory captured deeper images. Radio telescopes in the mid-1900s detected a powerful signal emanating from the same coordinates, a roar in the invisible wavelengths of space. M87 was no quiet galaxy. It was a dynamo, converting falling matter into pure radiation. Later, in the space age, the Hubble Space Telescope would show M87's jet in breathtaking detail, a luminous spear stretching into the black, glowing blue with magnetic fire. And the Event Horizon Telescope, centuries after Messier's first observation, would reveal the shadow of the black hole that powered it all, a ring of light around darkness itself. From that first faint note in Messier's catalogue to the moment humanity saw the unseeable, the story of M87 is one of perception expanding. It reminds us how fragile our definitions of small and simple truly are. What began as a blurry dot in an 18th century lens turned out to be a cosmic monarch, a trillion suns, a devouring heart, a radio storm echoing through time. Charles Messier never knew what he had found, but every astronomer who has looked into that same spot since has seen not just a galaxy, but a message, that the universe often hides its greatest wonders behind the faintest of lights. M87 holds more than 1 trillion stars, not scattered evenly, but flowing in a cosmic tide that glows like embers fading into the dark. Its sheer size makes our Milky Way seem delicate and small, a mere whisper beside a cosmic storm. Imagine standing at the edge of this galaxy, if such an edge could even be defined. The light of countless suns would spill across the horizon, too numerous to separate, too ancient to count. Each star a story, each beam of light a journey that began millions or even billions of years ago. M87 stars form a luminous ocean, vast, deep, and in constant motion, their combined radiance creating the smooth golden glow we see through telescopes here on Earth. Unlike the spiral pattern of our own galaxy, where stars trace graceful arms around a bright central band, M87's form is formless. It is a storm without symmetry, an immense sphere of starlight stirred by gravity and time. The stars are not arranged in orderly orbits but move like particles in a stirred glass of cosmic dust, colliding, merging, dispersing, and blending into the glowing mist. Each of these stars burns differently. Some are enormous blue giants, hot and short-lived, blazing through their fuel in just a few million years. Others are smaller, cooler, and ancient, red dwarfs that may outlive the universe itself. Most are old, much older than our Sun. They were born when the universe was young, their light carrying the faint memory of an age when the first galaxies were still forming. When you gaze at M87's pale glow, you are not seeing the light of the living, you are seeing the afterglow of ages past. Many of those stars no longer exist. Their light continues to travel through space, a message sent long ago that only now reaches our eyes. Every photon tells a story of what was, not what is. To observe M87 is to look into the past, into a history written in starlight. If you could drift among those stars, you would never find darkness. The sky would shimmer in every direction, each star glowing like a distant lantern. Gravity would tug gently from all sides, pulling you through the quiet void between suns. The distances between stars would still be immense, but the abundance of light would erase any sense of isolation. It would feel like floating inside the heart of eternity. Yet beneath this beauty lies violence. Many of M87's stars were not born here. They were stolen. As smaller galaxies fell into M87's grasp, their stars were stripped away, scattered, and absorbed. Over billions of years, this cosmic consumption has built the galaxy into the immense sphere we see today. The faint light in its outer regions comes from those captured wanderers, remnants of galaxies that no longer exist. It is strange to think that destruction can create something so magnificent. That the quiet glow we see through telescopes is the collective memory of a trillion cosmic collisions. M87's smooth light is not serenity. It is the product of endless chaos, long since slowed into stillness. And yet, even in that stillness, there is movement. Stars orbit the galaxy's hidden heart, a supermassive black hole that holds them all in place. Every flicker, every shimmer of gold across M87's surface, every faint wisp of light drifting outward, owes its existence to that gravitational anchor. In the end, to look upon M87 is to witness the universe at its grandest and most poetic, a sea of light born from fire, chaos, and time. An ocean where every wave is a star, and every ripple reaches us across millions of years, whispering softly of creation, destruction, and the quiet persistence of light. Surrounding M87 is a faint, luminous halo, a soft ocean of starlight stretching for 500,000 light-years. These are the remnants of countless galaxies devoured across time, their stars now drifting as ghosts in M87's gravitational sea. From Earth, this halo is nearly invisible. It can only be captured by telescopes capable of peering deep into the dimmest whispers of light. Yet, when astronomers enhance those faint glows, an ethereal structure appears, diffuse, ancient, and boundless. This is not merely the edge of a galaxy, it is a graveyard. The light we see here is the combined radiance of stars, stripped from smaller galaxies as they fell into M87's grasp. Over billions of years, their collective remnants have formed a mist-like veil, wrapping the galaxy in a spectral embrace. Each of those wandering stars follows a lonely path. They drift through the emptiness between galaxies, unbound to any one system, tethered only by M87's immense gravity. If you could hover within that halo, the view would be haunting. The core of M87 would blaze before you, bright and dense, while beyond it, faint threads of light would stretch outward, fading into the infinite dark. Around you, the stars would seem to hang motionless, their slow orbits measured not in centuries or millennia, but in tens of millions of years. These halo stars are survivors of cosmic violence. Long ago, smaller galaxies, fragile spirals, tiny ellipticals, and star clusters wandered too close to M87. Its tidal forces tore them apart, scattering their stars like grains of sand caught in a storm. What began as galaxies with their own histories, planets, and possible worlds was reduced to drifting embers. The light of their civilizations, if any had existed, would have been swallowed by time. The faintness of this halo makes it difficult to measure, yet it reveals an astonishing truth. M87's influence extends far beyond its visible core. The stars we can see are only part of its empire. Beyond them lies a vast population of dark matter. Invisible, but present, the gravitational glue that holds this luminous fog together. The halo is the physical echo of the galaxy's hunger, and it hints at just how many cosmic neighbors have fallen victim to it. In that sense, M87 is both creator and destroyer. Its collisions ignite bursts of new star formation in the core, even as they erase the individuality of the galaxies it consumes. The halo is the balance point between those two roles, the space where destruction transforms into art. To look upon it is to witness entropy, frozen mid-dance, light born from loss, beauty carved from decay. Astronomers studying the halo describe it as intra-cluster light, a term that feels too clinical for what it represents. It is the ghost light of an entire cluster, the echo of galactic lives uncounted. The Virgo cluster around M87 is filled with this faint glow, an invisible web of scattered starlight connecting one galaxy to another. When long-exposure telescopes reveal this web, it becomes clear that M87's halo does not end where its light fades. It blends seamlessly into the larger cluster, linking the fates of thousands of galaxies into a single, interconnected whole. If you were to drift outward, beyond where the last star of M87's halo fades into nothingness, you might still feel its pull. Gravity lingers long after light disappears, and perhaps that is the lesson this halo whispers through the void, that nothing in the universe truly vanishes. These stars, torn from their homes and set adrift, continue to shine. Their light travels on, crossing millions of years, brushing against our telescopes and reminding us that even in loss, there is radiance. Around M87, the ghosts of galaxies are not silent. They shimmer, softly, in eternal remembrance. Where the Milky Way hosts a few hundred globular clusters, M87 commands over 12,000. Each is a glittering sphere of ancient suns, relics of cosmic history that swarm like fireflies in orbit around a sleeping titan. Imagine a night sky not filled with stars, but with entire clusters of them, tiny galaxies in miniature, orbiting a colossal world. That is the view near M87. Spread across hundreds of thousands of light years, these globular clusters drift like glowing embers in a silent sea. Each cluster holds hundreds of thousands, sometimes millions, of tightly packed stars bound together by gravity, suns that have burned since the dawn of cosmic time. If you could fly through this swarm, it would feel like moving through a cosmic beehive. The clusters vary in color, some golden with age, others tinged blue with younger stars or newly merged systems. They shimmer softly against the blackness of space, appearing like suspended jewels scattered around an invisible throne. From afar, they are points of light. Up close, each is a world unto itself, dense enough that a night sky from within one would never truly grow dark. These globular clusters are not just beautiful, they are ancient. Many are over 12 billion years old, meaning they formed soon after the universe itself began to cool from the fires of the Big Bang. They contain some of the oldest stars ever known, stellar fossils, untouched by time, preserving the chemistry of a young cosmos. Their stars are poor in heavy elements, which tells astronomers that they were born before those elements even existed in abundance, before supernovae had seeded the universe with the materials for planets and life. The sheer number of these clusters around M87 tells us something profound about its history. Galaxies collect globular clusters the way oceans collect shells. The more shells you find, the more waves have passed. In the same way, M87's extraordinary population of clusters suggests a turbulent past, one marked by collisions, mergers, and feasts. Each cluster may have belonged to a smaller galaxy long ago, one that was drawn in and consumed. Over time, as those galaxies were shredded, their clusters survived, circling their new host like loyal satellites. It is as though M87 has built a crown of ancient light around itself, a halo not of starlight, but of memory. Each cluster traces an orbit that can take millions of years to complete. Some dive toward the galaxy's center, swinging close to its supermassive black hole before flinging outward again. Others drift in the outer reaches, where gravity weakens and the boundaries between galaxy and intergalactic space blur. When viewed through the Hubble Space Telescope, these clusters appear as pinpricks of brilliance scattered across the galaxy's glowing halo. They seem random at first, but their arrangement follows a delicate order, a gravitational choreography governed by M87's immense mass. Some clusters even show signs of motion influenced by the central black hole's pull, their paths bending subtly as they orbit through curved space-time. For astronomers, these clusters are more than decoration, they are clues. By measuring how they move, scientists can estimate the true mass of M87, including the invisible dark matter surrounding it. Each cluster's motion is a data point, a whisper from the galaxy's gravitational field. Together, they reveal that M87's weight is far beyond what its light suggests, confirming that dark matter dominates its structure. To the imagination, however, the swarm is something more poetic. It is the galaxy's heartbeat, a living system of light and gravity. Every glowing cluster a memory, every orbit a measure of cosmic time. And as you drift outward through this celestial cloud, past thousands of glittering orbs circling an unseen monarch, you realize something humbling. Even in a universe ruled by dark energy and distance, beauty still gathers itself into patterns. Around M87, that beauty takes the shape of ancient fireflies, drifting, shimmering, and eternal. At the galaxy's core lies a supermassive black hole so vast that even light must bow to it. With a mass of 6.5 billion suns, M87 distorts time itself, pulling nearby matter into spiraling orbits of incandescent fire. It sits like an eye in the center of eternity, invisible, yet commanding everything around it. From a distance, M87's heart appears tranquil, a golden glow softly radiating through its dense core. But within that glow lies a maelstrom of unimaginable violence. Gas, dust, and shattered remnants of stars are caught in the black hole's gravitational grip, spinning faster and faster as they fall inward, heating to millions of degrees. In that final desperate spiral, matter transforms into pure energy, a last flash of light before vanishing forever. If we could hover safely near its edge, we would see time itself stretch and bend. Seconds near the event horizon would pass as centuries beyond. Space would twist into impossible shapes. The background stars would smear into rings of light as their photons bent around the black hole's gravity. This is not the quiet darkness of night. This is a storm of space-time itself, a wound in the universe that never heals. The glowing disk surrounding M87, the accretion disk, is one of the most extreme environments known to physics. It shines brighter than the combined starlight of entire galaxies. Even though it occupies a region no larger than our solar system, magnetic fields thread through the plasma like luminous veins, channeling charged particles along unseen paths. Some of those particles never fall in. Instead, they are flung outward, guided by magnetism and rotation, forming the colossal jet that extends thousands of light years into space. Every photon emitted from this region tells a story of transformation, of matter becoming energy, and energy becoming motion. Around M87, nothing is wasted. The black hole feeds, and in doing so, it powers the galaxy's most breathtaking structures. Even from Earth, 53 million light-years away, we can detect its presence not by what it emits, but by what it takes, the light that vanishes, the shadow it leaves behind. In 2019, humanity saw that shadow for the first time. The Event Horizon Telescope, a network of observatories spread across the planet, captured the faint, ring-shaped glow of M87. It wasn't a photograph in the traditional sense, but an image made of radio waves, the silhouette of the unseeable. For the first time, we glimpsed the outline of a black hole's event horizon, a boundary beyond which space and time cease to exist. That glowing ring became an icon of human curiosity, proof that the laws of physics remain intact even in the face of the infinite. And yet, that shadow is not still. Over the years since, astronomers have noticed subtle changes, bright spots drifting around the ring, shifting in rhythm like flickers of thought. These variations hint at turbulence in the accretion flow, at magnetic storms and cosmic winds sweeping across the event horizon. The black hole may seem eternal, but its surroundings are alive, fluid, dynamic, evolving. To comprehend M87 is to confront our own limitations. Its gravity distorts not only space but imagination. How do we describe something that has no surface, no color, no boundary, only influence? Its presence is defined by absence, its shape by the light it devours. And yet, in that paradox lies beauty. If you could watch M87 from afar, you'd see not destruction but balance, the quiet exchange between order and chaos. The black hole consumes, yes, but it also gives light, motion, energy. It fuels the galaxy's jet, heats the interstellar medium, and sculpts the environment of an entire cluster. M87 is not a monster, it is an engine, a generator of structure and a guardian of balance. Its darkness is not evil, it is essential. Within that dark heart, the universe remembers how to create anew. And somewhere, deep inside its shadow, the laws of nature fold into themselves, waiting for the next wave of human wonder to ask, once again, what lies beyond the edge of everything? In 2019, the Event Horizon Telescope revealed what no one had seen before, the glowing ring of light around M87's black hole, a perfect silhouette carved into space. It was the first direct image of a black hole's shadow in human history. The image appeared simple, a dim, fiery ring surrounding a dark center. But behind that glowing outline lay centuries of questions, decades of effort, and a moment that forever changed the way humanity sees the universe. For the first time, we could look upon the very edge of existence, the boundary where light itself fails. It was not an artist's impression or a simulation. It was real, a photograph of the impossible. The Event Horizon Telescope, or EHT, was not a single telescope but a network of them. 8 observatories scattered across the planet, synchronized to act as one enormous eye. From the peaks of Chile's Atacama Desert to the icy heights of the South Pole, dishes thousands of miles apart were connected through atomic clocks that kept time with unimaginable precision. Together, they formed a virtual telescope the size of Earth itself. Only such an instrument could resolve something as distant and small as the shadow of a black hole in another galaxy. The data collected were immense, petabytes of information stored on hard drives, flown across continents because the files were too large to send digitally. Teams of scientists spent years piecing those signals together, aligning every fluctuation, filtering noise from the hum of the cosmos. The result was that now iconic image, a ring of fire suspended in the void, light bent and stretched by gravity until it encircled the shadow of nothingness. That shadow is not the black hole itself. It is the absence of light, the region from which no photon can escape. The glowing ring is the last resistance of the universe's fastest travelers, light particles spiraling around the event horizon before surrendering to the darkness. What we see is a gravitational mirage, the warped reflection of radiation emitted by matter just before it disappears forever. When the image was first revealed to the world, scientists and dreamers alike fell silent. Some wept, others simply stared. It was as though the universe had finally allowed us to peek behind its curtain. The theories of Einstein, equations written in chalk a century earlier, had been proven in a single, breathtaking picture. The ring's diameter matched the predictions of general relativity perfectly. And yet, beyond the science, there was something deeply human in that moment. It was the collective realization that we had seen our first true glimpse of the infinite. The faint orange glow of M87's black hole wasn't just light from another galaxy, it was a reflection of human perseverance, of countless minds reaching together across time and space. Since that day, the EHT has continued to refine its vision. Scientists found that the ring's brightness shifts, suggesting that the plasma near the event horizon is turbulent and alive. What was once a still photograph is now becoming a moving picture, a slow, cosmic dance unfolding across years. If you look closely at that image, you might sense something more than just science. You might see the quiet poetry of the cosmos. How light bends gracefully around the edges of oblivion. How even in darkness there is design. The universe did not hide its secrets from us out of cruelty. It waited until we were ready to understand them. When the first shadow appeared, it wasn't just a triumph of astronomy. It was a moment of connection between humanity and the vastness that created it. A reminder that even the darkest places in the universe are framed by light. And in that single image of a glowing ring, suspended in silence, 53 million light-years away, we found both an answer and an invitation, proof that the universe still holds mysteries vast enough to make us dream. But how large is a galaxy like M87, truly? Astronomers realized that defining its edge is impossible. It doesn't stop, it fades, extending so far that even light scattered through its outer halo continues to drift for hundreds of thousands of years. When we think of galaxies, we imagine them as isolated islands in space, clear shapes suspended in the dark, spinning majestically with some defined boundary. But M87 breaks that illusion. It refuses to be confined to a number, a measurement, or a diagram. It is too vast, too subtle, and too intertwined with the universe around it. The further astronomers looked, the less they could agree on where it ended. Some said it stretched for 120,000 light-years. Others argued it was 10 times that. In truth, M87's size depends on how you choose to measure it, by its stars, its gravity, its light, or its influence. Through long-exposure telescopes, its brightness fades gently into the background, blending with the faint glow of the Virgo Cluster itself. The galaxy doesn't have an edge, it has a gradient, a soft transition from something to nothing, from visible to invisible. Beyond the reach of its main body lie orphan stars and thin streams of light, wandering remnants from smaller galaxies devoured long ago. These stellar outcasts still feel M87's gravitational pull, orbiting silently hundreds of thousands of light-years from the core. If we define a galaxy by where its light stops, M87 is enormous. But if we define it by where its gravity weakens, by where its influence ceases to shape other galaxies, then its size becomes almost unimaginable. M87's gravitational reach extends across millions of light-years, tugging gently at the motions of its neighbors, anchoring the Virgo Cluster around it like a cosmic sun at the center of a vast solar system. It is not merely a galaxy, it is the heart of an empire. Within its invisible dominion, galaxies drift like planets, their paths subtly bent by its gravity. Even the hot gas that fills the cluster, glowing in X-rays millions of degrees hot, is sculpted by M87's mass. It creates ripples in the plasma, sound waves echoing through the cluster's gas, resonating across millions of years. Astronomers have tried to define its borders through different methods. By tracing the light of its stars, by mapping the distribution of globular clusters, by measuring the movement of galaxies around it. Each method gives a different answer, all of them staggering. At the faintest detectable limit, M87 could be nearly 1 million light-years across, large enough to swallow our Milky Way, Andromeda, and every smaller galaxy in between. Yet, there's something poetic in its lack of definition. In a universe that thrives on borders, planets, orbits, stars, and systems, M87 is a reminder that some structures exist beyond human categorization. Its light fades not because it ends, but because our tools can no longer follow it. Somewhere out there, in that faint glow that merges with the cosmic background, M87 continues. Infinite to us, simply because we cannot see its conclusion. And maybe that's the true beauty of it, not in its exact measurement, but in its mystery. The realization that some things in the universe are not meant to be reduced to a number, but to a feeling. The feeling of vastness, of quiet enormity, of standing beneath a night sky and knowing that out there exists something so immense, so patient, that it doesn't care where we choose to draw its edge. M87 defies boundaries because the universe itself has none. It's a gradient of existence, light fading into darkness, gravity dissolving into silence, energy stretching into eternity. To measure M87 is to measure the unmeasurable, not with instruments, but with awe. Unlike spiral galaxies, whose arms define them, elliptical giants like M87 blur into intergalactic space. Its edges dissolve into the surrounding cluster, making it more of a region than an object, a gravitational empire without walls. To understand M87 is to realize that not all galaxies are confined within clean, elegant outlines. Spirals like our Milky Way are beautifully structured, shaped by rotation and delicate lanes of dust. But M87 is different. It's an organism of gravity, not geometry. It has no symmetry, no arms, no clear edge. Instead, it's a glowing fog of ancient stars that simply fades into the void, its light dissolving so gradually that you cannot tell where the galaxy ends and where space begins. If you were to drift outward from its bright center, the stars would thin like mist. First, you'd pass through dense regions of golden light, billions of suns orbiting in every direction, their motion chaotic and uncoordinated. There is no flat disk here, no graceful spin, only random paths, each star wandering like a leaf in an unseen current. Then, further still, the light would dim to a faint haze. Beyond that, the last few stars would appear like distant sparks, separated by unimaginable emptiness. And still, the galaxy would continue. That's because M87 doesn't exist as an isolated island. It bleeds into the Virgo Cluster, merging seamlessly with the light and gravity of the galaxies around it. Its outer halo is threaded with the remnants of smaller galaxies, faint streams of starlight, torn apart and reabsorbed over billions of years. These stars are neither fully M87s nor truly separate. They live in a liminal space between one world and the next, the borderless frontier of galactic existence. To astronomers, M87 is not just a single structure, but the gravitational hub of an entire cosmic metropolis. Its reach defines the behavior of thousands of galaxies in the Virgo Cluster. Some orbit it, others fall toward it slowly, destined to merge over eons. The boundaries of M87 are not drawn in light, but in influence. Its presence can be felt across tens of millions of light years, shaping the orbits of galaxies like tides pulled by an invisible moon. And yet, even in this vastness, M87 is not chaotic. Its form, though seemingly formless, follows a quiet pattern dictated by physics. Gravity smooths out irregularities, pulling everything toward equilibrium. Over time, the scars of collisions fade, and what remains is serenity, a soft gradient of light that looks almost tranquil. But that tranquility is deceptive. Every photon escaping M87's core began its journey amid chaos, collisions, mergers, and the cannibalization of entire galaxies. Its peace is the kind that follows great storms. This lack of defined borders gives M87 a kind of cosmic humility. It reminds us that not everything in the universe fits neatly into human categories. We crave boundaries, beginnings and endings, insides and outsides, but M87 doesn't provide them. It exists instead as a continuum, a region of influence rather than a shape. It is both a galaxy and part of the greater whole. In a way, M87 mirrors the nature of the universe itself, infinite, continuous, interconnected. Its edges dissolve not because they are weak, but because gravity knows no limits. Just as oceans blur into the sky at the horizon, M87 fades into the cosmic sea around it. It is both an individual and a collective, both an object and a field. If you could step back far enough, beyond the Virgo cluster, beyond the light of nearby galaxies, you might see M87 as a pulse of brightness amid the darkness, a single glowing node in a web of countless others, each connected, each influencing the next. So, when we look at M87 and try to measure where it ends, perhaps we're asking the wrong question. It doesn't end, it blends. It isn't a thing, but a state. A gravitational empire without walls, forever dissolving into the fabric of space, reminding us that in the grandest scales of the universe, nothing is ever truly separate. M87 is not alone. It sits at the gravitational heart of the Virgo cluster, anchoring over 2,000 galaxies. Its gravity binds them all, orchestrating their slow motion in a cosmic ballet spanning tens of millions of light years. From a great distance, the Virgo cluster resembles a web of faint light suspended in a black ocean. Every pinpoint glow is a galaxy, and together they form one of the largest structures in our cosmic neighborhood. At its center sits M87, vast, silent, ancient, like a monarch surrounded by its courtiers. Around it, the cluster's galaxies drift slowly through intergalactic space, tracing invisible orbits governed by M87's immense gravitational field. To understand the Virgo cluster is to see scale on a level that defies imagination. The cluster spans more than 10 million light-years across, a vast congregation of galaxies bound together not by proximity, but by gravity. Within it are spirals and ellipticals, dwarf galaxies and irregulars, each with its own billions of stars, its own worlds, its own histories. And though each galaxy may appear to float freely, they are all linked through an intricate gravitational dance. Their motions are slow, their paths curved and gentle, but over cosmic time, M87's pull draws them ever closer. In this grand system, M87 plays the role of both anchor and architect. Its enormous mass creates the gravitational well at the cluster's core, a basin into which everything else eventually falls. Smaller galaxies spiral inward like leaves caught in a whirlpool, merging and fading into the cluster's luminous heart. Others orbit at vast distances, moving so slowly that one complete revolution could take billions of years. To the human eye, it looks still, a frozen pattern of light, but it's not still at all. Its motion at a speed too vast for our short lives to perceive. The space between these galaxies isn't empty, either. It's filled with hot gas, millions of degrees in temperature, glowing faintly in X-rays. This intergalactic medium is a kind of invisible atmosphere for the cluster, shaped by the same forces that govern M87's jet and halo. Every time the black hole at M87's center exhales energy, shockwaves ripple through this plasma, creating vast bubbles and sound waves that echo for millions of years. The Virgo cluster doesn't just move, it breathes. From Earth, we are on the cluster's outer edge. The Milky Way, along with our local group of galaxies, drifts toward Virgo at a slow but inevitable pace, a fall so gentle that it will take billions of years to complete. When astronomers map the motion of nearby galaxies, they find that many of them, even those far beyond the cluster itself, are being subtly drawn in by Virgo's gravity. M87's influence, spread through the cluster's core, extends far beyond what we can see. It's humbling to realize that our own galaxy, vast as it seems, is just a tiny ripple in a larger tide. The Virgo cluster represents the next level of cosmic organization, a collection of galaxies bound together in an endless waltz. And at the center of that dance, M87 shines like a crown jewel, ancient, steady, and immeasurably powerful. Over unimaginable spans of time, this cluster will change. Galaxies will merge, collisions will birth new stars, and others will fade into darkness. But M87 will remain, absorbing what comes too near, shaping the structure of the cluster long after our sun has burned away. It is both a ruler and a witness, presiding silently over a realm of galaxies, each one a universe in itself. When we look at M87 in this way, not as a single galaxy, but as the gravitational heart of thousands, its true scale becomes clear. It is not simply large, it is foundational. The Virgo cluster revolves around it, and in doing so, defines the architecture of our local universe. M87 is more than the crown of Virgo. It is Virgo. The light of its countless stars, the weight of its gravity, the reach of its influence, all of it stretches across tens of millions of light years. It is a reminder that even in the quiet vastness of space, structure exists, order arises. And from one brilliant center, an entire cluster of galaxies finds its rhythm in the darkness. From the galaxy's center bursts a jet of energy, nearly 5,000 light-years long, a beam of matter accelerated to near the speed of light, glowing in ultraviolet and radio frequencies, painting a bright line through the darkness. This jet is one of the most awe-inspiring sights in the cosmos, a cosmic spear of plasma that pierces the void with unimaginable power. It emerges from the very edge of the supermassive black hole, where space and time are twisted into knots. There, gravity and magnetism conspire in ways that defy common sense, transforming infalling matter into a stream of pure energy. From that violence comes beauty, a luminous beacon shining across millions of light years. To an observer in orbit around M87, this jet would be breathtaking. You would see a column of light so intense it would outshine the stars around it. It would pulse and flicker, dancing with turbulence as charged particles spiraled along magnetic field lines. The colors would depend on your eyes. In visible light, it would glow faintly blue. In ultraviolet, it would blaze with radiance. In radio frequencies, it would hum with ghostly power, invisible but strong enough to shake the very medium of space. The jet begins close to the black hole, where material swirling in the accretion disk becomes trapped in powerful magnetic fields. Some of this matter, mostly electrons and protons, avoids falling inward. Instead, it is funneled along the poles of the black hole's rotation axis and flung outward at nearly the speed of light. These particles travel so fast that time itself slows for them. What might be a moment for us could be centuries for them as they blaze through the cosmos. Even after thousands of light years, the jet doesn't simply fade away. It remains coherent, like a focused beam, cutting through the interstellar medium. It interacts with the surrounding gas, shocking and heating it, carving cavities in the hot plasma that fills the Virgo cluster. These voids, detected in X-rays, are vast, each larger than our entire Milky Way. The jet's energy sculpts the environment of the cluster, influencing the formation of galaxies and stars far beyond M87's visible reach. It is strange to think that something so destructive could also be so creative. The same forces that tear apart stars and devour matter also breathe life into the galaxy around them. The jet injects energy into the surrounding gas, preventing it from collapsing too quickly. It stirs the cosmic medium, maintaining a delicate balance between chaos and order. Without it, the hot gas around M87 might cool and form new stars in rapid bursts. But with the jet, that process is moderated, stretched over billions of years. In this way, the black hole doesn't just consume, it regulates. It shapes the rhythm of creation itself. Astronomers have traced the jet across wavelengths, from radio to optical to X-ray. In every spectrum, it tells the same story, a story of motion, heat, and transformation. Its structure is not uniform. It ripples, twists, and occasionally flares, as if the black hole's heartbeat echoes through it. Some sections appear brighter than others, perhaps where shock waves compress the plasma, or where turbulence briefly amplifies the light. These variations reveal the living nature of the jet. It is not static, but dynamic, breathing, evolving. When scientists first captured clear images of the jet using the Hubble Space Telescope, they were struck by its scale and precision. It was the first time humanity had seen a black hole's power made visible on such a vast canvas. And even from 53 million light-years away, the jet remains bright enough to be seen with smaller telescopes, a reminder of just how much energy is unleashed at M87's heart. If you think of the black hole as a destroyer, the jet is its paradox. Destruction transformed into creation. From darkness comes light. From gravity, energy. It is as if the galaxy's core whispers that even in the deepest voids, there is motion, purpose, and renewal. As you drift away from M87's glowing center, the jet continues to shine behind you, a thin, radiant scar against the black canvas of space. It is both a wound and a masterpiece. And like all things in the universe, it is temporary, destined, one day, to fade. But tonight, across the vast silence of the cosmos, it burns with the light of 1,000 galaxies, reminding us that even in the shadow of annihilation, creation never truly stops. That jet is forged by magnetic chaos near the black hole's event horizon, wherein falling plasma twists and launches into space. The energy released there is so immense that it can outshine entire galaxies. This process is one of the most mysterious and magnificent acts in the cosmos, the creation of light from darkness. It begins in the furnace of gravity, where gas and dust spiral into the black hole at nearly the speed of light. The closer they fall, the hotter they become, until the matter glows with X-rays and gamma rays, hotter than any star could ever be. But just before this material crosses the event horizon, the point of no return, a strange thing happens. Not everything falls in. Some of it is saved, hurled outward through invisible channels of magnetism. The region around M87's black hole is a storm of electromagnetic fields. The plasma, made of charged particles, drags these fields as it spins. This twisting motion winds the magnetic lines into a spiral, a helix of pure force that funnels material away from the black hole's surface. What should have been consumed becomes accelerated instead, transformed into a beam of plasma traveling outward at nearly the speed of light. It is one of the universe's most paradoxical miracles. A black hole, an object famous for swallowing everything, becomes the engine of one of the brightest phenomena in existence. Through this process, known as the Blandford-Znajek mechanism, rotational energy from the black hole itself is extracted and converted into motion, light, and heat. In essence, the black hole becomes a cosmic dynamo, generating energy from its own spin. If we could hover near the event horizon, we would see this process in staggering detail. The accretion disk would shimmer like molten gold, its plasma whipping around at relativistic speeds. Arcs of magnetic lightning would flash across the surface, each strong enough to shred a planet into vapor. As the magnetic field lines tightened, they'd snap and reconnect, flinging matter outward in jets that scream through space with almost unimaginable speed. Time would warp around us, light bending into halos as gravity distorted our view of the universe beyond. The jet that emerges from this maelstrom doesn't simply explode outward and fade. It remains astonishingly focused, like a beam guided by precision engineering. For thousands of light years, it stays narrow and coherent, bound by magnetic fields that keep it from dispersing. Within it, electrons spiral along those magnetic lines, emitting synchrotron radiation, light that stretches across the electromagnetic spectrum, from low-frequency radio waves to high-energy X-rays. To astronomers, that radiation is the fingerprint of the jet's creation, proof of the incredible energies at play. The power unleashed here is staggering. In a single second, the black hole's jet can release more energy than our sun will emit in its entire 10 billion-year lifetime. It's a scale so immense that even words like explosive or blinding fail to capture it. Yet, for all its violence, this process is elegantly balanced. It doesn't destroy the galaxy, it sustains it. The jet carries away angular momentum and excess energy, allowing new material to continue falling inward. Without that release, the accretion disk would choke, and the engine would stall. The jet is the pressure valve that keeps the heart of M87 beating. In 2025, the Event Horizon Telescope captured changes in the polarization of light near M87's jet, shifts in the magnetic fields themselves. These flips, as scientists call them, show how dynamic and unpredictable this region truly is. The magnetic field isn't constant, it pulses, reverses, and realigns, like the heartbeat of a living system. Each pulse may mark a new wave of material being ejected into the jet, a reminder that this process is not static but alive, evolving moment by moment. When we gaze upon the glowing spine of M87's jet, stretching across space like a celestial sword, we are witnessing this magnetic miracle, the birth of light from the fabric of darkness. It is a process that transforms destruction into creation, gravity into brilliance, silence into song. The universe is full of contradictions, and few are as beautiful as this one. At the heart of a black hole, the ultimate symbol of nothingness, lies the mechanism to create light, powerful enough to illuminate entire galaxies. M87 teaches us that even in the deepest wells of gravity, the cosmos finds a way to shine. In 2025, the Event Horizon Telescope confirmed that M87's black hole ring had barely changed over years of observation, a cosmic heartbeat frozen in time, proving Einstein's predictions about gravity and light once again. It's one of the most quietly astonishing discoveries of modern astronomy. The realization that, in the most turbulent region of the universe, there is near-perfect stability. Around a supermassive black hole, where matter spirals at near-light speed and magnetic fields twist like living storms, we might expect chaos. We might expect the shadow to pulse, expand, or warp as the flow of matter changes. Its shape, its scale, its glowing ring of fire remains almost unchanged, as though space itself is holding its breath. When the first image of M87's black hole was released in 2019, it was hailed as a triumph of science and human collaboration. Yet some skeptics wondered, was it just a fleeting snapshot? Could the glowing ring, that fiery halo around the shadow, vary from year to year as matter fell in, heated, and flared? The Event Horizon Telescope continued to observe, patient and precise, comparing the data from multiple years, 2017, 2018, 2021. By 2025, the verdict was clear. The ring endures. The measurements showed the ring's diameter, about 43 microarc seconds, the width of an orange on the moon, as seen from Earth, remained steady within a fraction of a percent. The brightness shifted slightly, the hot spot moved, but the structure held firm. The shadow stayed the same size because it is defined not by the black hole's feeding habits, but by the very geometry of space-time itself. Its diameter corresponds directly to the black hole's mass, and that mass doesn't change on human timescales. This stability is a cosmic signature, a confirmation that Einstein's theory of general relativity still holds true, even in the most extreme environment imaginable. According to relativity, the shadow's size depends only on mass and distance. No matter how violently the plasma around it flickers, no matter how magnetic fields twist or turbulence surges, the event horizon's boundary remains fixed. To scientists, it's as though M87 is a clock ticking in slow motion, its steady pulse marking the rhythm of the universe. The glowing ring isn't constant light, it's constantly refreshed, new photons replacing old ones as matter continues to fall in. But the outline they trace, the curved path around the black hole's gravity, never changes. It is space-time itself bending light into a perfect circle, over and over again. And yet, even in this constancy, there is motion. In 2025, researchers noted that the brightest part of the ring, the hot spot, had drifted slightly counterclockwise since 2019. This subtle shift is not random. It's the signature of turbulent gas orbiting close to the event horizon. It takes days or weeks for this matter to complete one rotation. The hotspot's movement tells us that the black hole is feeding, quietly, rhythmically, a slow, patient meal that barely disturbs the geometry surrounding it. For astronomers, this discovery brings an almost meditative awe. In a universe defined by change, exploding stars, colliding galaxies, expanding space, here lies a region of utter stillness. M87's shadow is a symbol of permanence amid flux, a fixed window into infinity. It shows us that gravity, when pushed to its limits, becomes not just a force but a framework, a canvas upon which the universe paints, but which the painting can never alter. It's humbling to think that we can look across 53 million light-years and see something that has not changed in all the time since that light began its journey. The photons that reached our telescopes in 2025 left M87 before humans existed, before Earth's continents had their current shapes. And yet, when those ancient messengers of light arrived, they revealed a structure that, even across cosmic ages, remains perfectly the same. Perhaps that is why M87 fascinates us so deeply. It is both timeless and alive. Around it, plasma churns, magnetic fields writhe, and particles scream at near-light speed. And yet the shadow, the silent heart, endures. It is the closest thing the universe offers to eternity. The shadow that stays the same is more than an image, it's a message. It tells us that beneath the chaos, there is order. Beneath the storm, there is structure. And in the heart of the universe's most powerful force, there exists a kind of peace, a cosmic stillness that outlasts everything else. M87 is one of the strongest radio sources in the sky. Its jet creates ripples that extend thousands of light-years into the surrounding gas, forming vast radio lobes, expanding bubbles of energy sculpted by the black hole's breath. These ripples are not waves of sound as we know them, but cosmic undulations in the hot plasma that fills the Virgo Cluster. They are the footprints of energy unleashed by the supermassive black hole, echoes of eruptions that began millions of years ago. If we could translate them into sound, their notes would be impossibly deep, oscillating once every few million years. To our ears, they would be silence. But to the universe, they are music, a low, resonant hum reverberating through intergalactic space. Astronomers first discovered these radio lobes when they pointed powerful radio telescopes toward M87 and found that its light extended far beyond what optical telescopes could see. Where visible light showed a smooth, elliptical glow, radio observations revealed enormous, balloon-like structures stretching out from the galaxy's center. These were the remnants of ancient outbursts, waves of charged particles and magnetic fields blown outward by the black hole's jet, expanding like ripples in a vast cosmic pond. Each ripple marks a moment when M87's central engine flared to life. When the black hole's magnetic fields twist and snap, they unleash immense bursts of energy that blast through surrounding gas. These eruptions carve cavities into the cluster's plasma, displacing material and leaving behind pockets of lower density. Over time, the cavities rise buoyantly, like bubbles in boiling water, spreading heat and energy throughout the cluster. What's remarkable is that these bubbles are huge. Some are tens of thousands of light-years wide, large enough to swallow our Milky Way many times over. They drift slowly through the surrounding gas, carrying with them the fingerprints of their origin, magnetic filaments, relativistic particles, and echoes of the black hole's heartbeat. Even after the central jet quiets, these radio lobes continue to glow for millions of years, their light slowly fading as they cool and expand. The Chandra X-ray Observatory has imaged the hot gas around M87 and found evidence of these ripples as concentric arcs, like the rings formed when a pebble is dropped into still water. Each arc represents a separate outburst from the black hole, separated by tens of millions of years. The pattern tells us that M87's central engine doesn't roar constantly. Instead, it breathes, erupting, resting, then erupting again. Each breath reshapes its environment, ensuring that the surrounding gas never cools enough to collapse into new stars. In this way, the black hole regulates the galaxy's growth, preventing runaway star formation and maintaining a delicate cosmic balance. To visualize this, imagine the galaxy as a vast ocean of invisible gas, and the black hole as a volcano at its heart. Every so often, that volcano erupts, not with fire or ash, but with energy, sending waves across space. Those waves carry information: the strength of the eruption, the density of the gas, the geometry of the magnetic fields. By studying them, astronomers can reconstruct the history of M87's activity, like reading the rings of a cosmic tree. Even now, as we observe M87 through radio telescopes, those ancient ripples continue to expand. They are millions of years old, yet still moving, still reshaping the cluster's heart. Each wave carries the memory of a moment when the black hole spoke, when it released its pent-up energy into the void. The silence we see between eruptions is not death, but rest, the pause between breaths of a living system. In that sense, M87's radio lobes are more than relics of violence. They are evidence of balance, of a galaxy that sustains itself through rhythm and release. The black hole exhales, the gas stirs, and the cluster remains stable. Without these periodic outbursts, the surrounding plasma would cool, collapse, and form new stars uncontrollably. But the ripples keep the system in harmony, distributing energy like the steady beat of a cosmic heart. When we look at M87 through the eyes of a radio telescope, we aren't just seeing light, we're seeing motion. We're watching time made visible, energy turned into art. The universe has few constants, but here, in these ripples, we glimpse one. The cyclical breath of creation and destruction played out across millions of years. And so, M87 sings in radio waves, a deep, timeless hum that carries through the cluster's sea of gas. It's a song we can't hear, yet somehow we feel it. The rhythm of a living galaxy, resonating quietly through the darkness, reminding us that even silence in the universe is never truly still. The gravitational influence of M87 extends far beyond its visible edge. Stars and satellite galaxies orbit its center like moons around a planet, bound within an invisible web of gravity that stretches across intergalactic space. Gravity is the quiet architect of the cosmos, unseen, intangible, but relentless. Around M87, its pull becomes an empire. Though the galaxy's light fades after hundreds of thousands of light years, its gravity does not. It stretches deep into the surrounding void, shaping the motion of galaxies across millions of light years. To the eye, it seems as though M87 ends in a faint glow, but to physics, it never ends at all. Its presence ripples through the Virgo cluster, defining the slow, swirling dance of everything within it. If you could map the gravitational field of M87, it would look like a vast ocean, a sea of invisible curvature in space-time. Every star, every cluster, every wisp of dark matter bends the cosmic fabric slightly, creating eddies and tides. At the center of that ocean sits M87's supermassive black hole, the deepest well of gravity in the region. But its influence is magnified by the galaxy itself, by the combined mass of 1 trillion stars, the dark matter halo surrounding them, and the endless stream of satellite galaxies caught in its grip. These satellites are like companions in orbit, smaller galaxies that have long since surrendered to M87's dominance. Some are bright ellipticals, others are faint smudges of stars barely holding together. Over billions of years, they have been drawn inward, their paths elongated and twisted by gravitational tides. Some will survive as permanent satellites, others will spiral inward, torn apart and absorbed into M87's glowing body. In this way, the galaxy grows, not by birth, but by consumption. Astronomers studying the motions of these satellites have found that M87's mass far exceeds what its starlight can account for. The visible matter, the stars, gas, and dust, makes up only a fraction of its total weight. The rest is dark matter, an invisible halo extending far beyond the luminous edge, sculpting the motions of galaxies like an unseen hand. It is this dark matter that gives M87 its extraordinary gravitational reach, its unseen web of influence woven through the Virgo cluster. The scale is staggering. A single orbit around M87's center could take billions of years to complete. A satellite galaxy 500,000 light-years away would drift along its path so slowly that even in the lifetime of civilizations, it would scarcely move. To witness one orbit in full would be to outlive stars, planets, and perhaps the concept of time itself. And yet, even at such distances, M87's gravity can be felt. The hot plasma between galaxies bends toward it. The trajectories of other cluster members curve subtly in its direction. It acts as an anchor, a gravitational lighthouse, guiding the motions of everything nearby. In a universe where most things drift aimlessly, M87 gives order to chaos. What's more astonishing is that this gravitational dominance is not confined to baryonic matter, the atoms and particles that make up stars and worlds. It extends into the dark sector, shaping the behavior of unseen matter that outweighs the visible universe by a factor of 5. M87 is thus not only a beacon of light, but also a shadowy ruler of dark matter, a structure so massive that even the invisible must obey its pull. To visualize this reach is almost impossible. Imagine floating in intergalactic space, millions of light years from M87. The galaxy would appear as a faint, glowing pearl. You'd feel weightless, adrift in silence. But mathematically, you'd still be falling, gently, imperceptibly, toward that pearl of light. Its pull would be slight, but constant, tugging you across time itself. This is the true majesty of M87. It doesn't just occupy space, it defines it. Its gravity carves the very shape of the Virgo Cluster, drawing galaxies into subtle alignment, orchestrating the slow cosmic waltz of matter across millions of light years. And somewhere in that vast gravitational field, far out on its periphery, drifts our own Milky Way, pulled ever so slightly toward the cluster's heart. We are distant, small, and insignificant compared to M87, yet we are connected to it. Its gravity reaches us too, across the cosmic gulf, whispering through the fabric of space-time. In that whisper lies a reminder. In the universe, nothing is truly alone. Every galaxy, every star, every particle exists within the pull of something greater. And for the Virgo Cluster, that something greater, that quiet, unseen force, is M87, the giant whose reach knows no bounds. Astronomers estimate M87's total mass, including dark matter, at more than 3 quadrillion times the mass of the Sun. That's not just large, it's nearly incomprehensible, a scale that stretches imagination to its breaking point. Numbers this immense lose meaning quickly. To understand them, we have to step outside the comfort of comparison and into the realm of awe. 1 quadrillion is a million billion, a number so vast it can't be visualized in the mind's eye. Now, multiply that by 3, and you begin to approach the true scale of M87. It's a galaxy so heavy that its gravity bends not just light, but the shape of the universe around it. If the Milky Way were placed beside it, our home galaxy, with its 200 billion stars, would appear almost delicate, like a feather resting next to a mountain of stone. The reason for this colossal mass isn't just the sheer number of stars within M87, though there are trillions of them. The true weight of the galaxy comes from what we can't see. Dark matter, the invisible scaffolding of the cosmos, accounts for most of it. This mysterious substance neither emits nor absorbs light, but it reveals itself through gravity. Without it, galaxies like M87 couldn't exist. The stars alone don't have enough mass to hold themselves together. It's the dark matter halo, sprawling far beyond the visible edges, that provides the glue. Imagine M87's dark matter halo as a vast, invisible bubble, perhaps a million light-years across, inside which everything else drifts. Stars, planets, gas, and even smaller galaxies. It's not solid or smooth, but laced with structure, a cosmic web of density fluctuations that determine where galaxies form and how they evolve. In that sense, M87's visible light, all those golden stars we see through telescopes, is just a trace of something much larger, a faint sparkle floating in an unseen ocean of mass. This mass gives M87 enormous power. Its gravitational field sculpts the motion of galaxies within the Virgo Cluster. It holds the hot, X-ray emitting gas that fills the space between galaxies, preventing it from escaping into the void. Even its central black hole, 6.5 billion solar masses strong, is a mere fraction of the galaxy's total weight. The black hole may rule the heart, but the dark matter rules the realm. When astronomers attempt to measure this mass, they do it indirectly. They track the motion of stars near the center, then the orbits of globular clusters, and finally, the movement of satellite galaxies at the outskirts. What they find is astonishing. The speed of stars and clusters remains high even far from the core, long after visible matter thins away. That means something unseen is still pulling them. A gravitational presence that refuses to fade with distance. Even light cannot escape M87's influence. When photons from background galaxies pass nearby, they bend slightly, their paths curved by the galaxy's gravity. This effect, known as gravitational lensing, allows astronomers to glimpse the invisible. By studying how M87 distorts the light behind it, scientists can infer the shape of its dark matter halo and confirm that most of its mass lies far beyond what our eyes can see. If you could compress M87's mass into a single sphere, it would crush atoms into oblivion. The density of such a structure defies comprehension, not because the galaxy itself is dense, it isn't. Much of it is empty space, but because of how far its mass extends. It's spread over millions of light years, an enormous gravitational gradient that dictates the motion of entire galaxies. Standing beneath a clear night sky, it's humbling to realize that this one galaxy, 53 million light-years away, outweighs everything in our local group combined. The Milky Way, Andromeda, and their satellites. It is a gravitational monarch whose dominion spans a region of space we can scarcely fathom. And yet, even in all that mass, there is fragility. M87's structure, while ancient, is not eternal. Over billions of years, galaxies will continue to fall toward it, merging and deepening its gravitational well. But even that growth has limits. As the universe expands faster and faster, the space beyond the Virgo cluster will drift away, unreachable forever. M87 will eventually become an island in an endless sea, a self-contained universe, its immense mass holding on to what little remains. When we speak of M87's mass, we are not just describing a number, we are describing a truth about scale. A reminder that the universe operates on dimensions far beyond the reach of intuition. M87's weight bends the fabric of reality itself. It is not merely large, it is cosmic authority made manifest, a silent testament to the power and mystery of gravity, sculpting the universe one star, one cluster, one invisible particle at a time. M87 did not grow peacefully. Over billions of years, it devoured its neighbors. Galaxies drawn in, torn apart, and digested into its enormous halo. Every faint star in its outer glow tells the story of something that once was whole. To look upon M87 is to see the aftermath of countless acts of cosmic consumption. The galaxy's smooth, featureless light is deceptive. Beneath that calm facade lies a history of violence, of collisions so vast that entire civilizations, had they existed, would have been swept away in silence. For most of its existence, M87 has been a predator, feeding on smaller galaxies within the Virgo cluster. Its growth is written not in fire or sound, but in gravity, slow, patient, inevitable. When two galaxies meet, they don't collide like solid objects. They pass through one another, their stars rarely touching. But gravity does what matter cannot. It pulls, stretches, and reshapes. Stars are scattered, gas clouds compress, and orbits distort into chaotic loops. Over time, the smaller galaxy loses its shape, its stars stripped away and absorbed into the larger one's outer halo. Its central core may survive for a while, glowing faintly as a satellite before being drawn in completely. The result is an elliptical giant like M87, a creature built from the bones of its predecessors. Astronomers have traced this process in exquisite detail. Deep imaging of M87 reveals faint tidal streams, wisps of starlight arcing across the void, remnants of galaxies torn apart eons ago. These streams are ghosts, their light so diffuse that it nearly vanishes into darkness. Yet, they hold the evidence of M87's feasts, disrupted spiral arms, shattered cores, and the fading signatures of once distinct galaxies. In this sense, M87 is not a single entity but a graveyard, a monument built from the remains of countless others. Every star in its halo has a story. Some were born in the galaxies it consumed, others ignited in the chaos of the mergers themselves, when gas clouds compressed under gravitational tides. These newborn stars would have glowed bright blue for a short while before burning out, leaving behind clusters and remnants scattered across M87's outskirts. Over time, the energy of the collisions smoothed away the visible scars, leaving behind the soft, even light we see today. The evidence of this cannibalism doesn't just come from light, it comes from motion. Astronomers studying the velocities of M87 stars have found that many of them move in odd directions, their paths misaligned with the galaxy's central rotation. It's as if they were flung there by external forces, the lingering signatures of absorbed systems. Some globular clusters orbit along strange, tilted planes, relics of galaxies that once orbited the cluster's outskirts before being devoured. M87's appetite is not unique, but it is legendary. Galactic cannibalism is a natural part of cosmic evolution. The universe is hierarchical. Small galaxies form first, then merge to create larger ones. Over billions of years, this cycle repeats until giants like M87 emerge. Titans made from millions of mergers, colossal archives of cosmic history. Each star within them is a memory of something smaller that came before. If we could rewind time, we would see the Virgo Cluster teeming with smaller galaxies, delicate spirals, irregular clouds, and bright dwarfs drifting between the giants. M87 would have been at the center, a massive but hungry beast. Slowly, through gravity's endless patience, it would have pulled its neighbors inward, consuming them one by one. The process continues even now. Satellite galaxies still spiral toward it, caught in orbits that will one day end in dissolution. To call M87 a cannibal might seem poetic, but it is also literal in a cosmic sense. It feeds on the energy and matter of others. Every new addition strengthens its gravity, deepens its potential well, and expands its halo. Over time, its growth has slowed, not because it is satisfied, but because fewer galaxies remain nearby to consume. The cluster around it has thinned, leaving M87 as the dominant force, vast, solitary, complete. Yet even in its quiet dominance, the memory of violence lingers. The smooth glow we see through telescopes isn't peace, it's aftermath. The faint, golden haze around M87 is light from stars that once belonged to countless other galaxies, now unified under one gravitational rule. It's a paradoxical beauty. Destruction transformed into harmony, chaos distilled into serenity. In the end, M87 is both predator and archive, a living record of cosmic hunger. Its mass tells of power, its light tells of loss, and together they remind us that even in the grand stillness of space, creation is often born from consumption, that the universe builds its masterpieces from the remnants of what it destroys. The smooth light we see from M87 is the sum of countless mergers. Each collision stirred its stars into new orbits, erasing structure and leaving only a featureless sphere of light, beauty born from destruction. When we gaze upon M87 through a telescope, what appears calm and uniform is in truth the residue of violence on a cosmic scale. The faint, golden glow that fills its elliptical shape is not the light of peace, but the afterglow of chaos, the accumulated shimmer of 1,000 galactic collisions that reshaped everything into balance. Over billions of years, spiral arms were shattered, star clusters scattered, and the graceful order of smaller galaxies erased. What remains is this: a sphere of equilibrium born from disorder, a galaxy that has forgotten the shapes it once wore. In spiral galaxies like the Milky Way, motion has direction. Stars orbit the center in well-defined patterns, tracing elegant arms through the dark. But in elliptical giants like M87, those patterns are gone. Every merger, every gravitational encounter, scrambled the orbits of its stars, turning a once-ordered system into a stellar storm. Now, the stars move in all directions, each one a solitary traveler weaving through the gravitational sea. The result is a glow that looks deceptively smooth, like fog seen from a distance. But within that fog, billions of suns cross paths, each following a silent, unpredictable route. Astronomers call this process violent relaxation, a fitting phrase for what it describes. When two galaxies merge, their gravitational fields fluctuate wildly, tossing stars into new trajectories. Over time, those stars settle into statistical equilibrium, spreading evenly across the galaxy's volume. The sharp features of spirals and disks vanish, replaced by an even distribution of light. The term might sound clinical, but its poetry is undeniable. Through violence, the galaxy finds peace. If we could watch M87's formation in time-lapse, if billions of years could unfold before our eyes, we'd see a breathtaking transformation. A swirling ballet of galaxies drawn together by gravity, colliding in slow motion. Stars would burst forth as clouds of gas compressed under tidal forces. Entire systems would pass through one another, leaving behind tidal tails of starlight stretching for hundreds of thousands of light years. Then, gradually, the chaos would fade. The separate galaxies would dissolve into one. The luminous trails would dim, and the system would settle, not into silence, but into harmony. The stars within M87 are old now, most of them born long before Earth existed. Their light is a deep golden hue, the color of age. The blue stars, massive, short-lived beacons of youth, are rare here. They burned out long ago, leaving behind only the long-lived red and yellow suns that fill the galaxy with warmth. It's a mature light, like the embers of a fire that once raged bright. The brilliance of its past remains, diffused and softened, like the final glow of creation winding down. Even the galaxy's shape tells this story. Its lack of defined features, no spiral arms, no dust lanes, is not emptiness but memory. It's the result of countless collisions, smoothing away individuality, blending the histories of thousands of galaxies into one collective form. The light of M87 is, in essence, the light of everything it has absorbed. To astronomers, the brightness of that glow is not just aesthetic, it's data. Each point of light carries information about the ages, compositions, and motions of the stars. By studying how that light shifts and spreads, scientists can reconstruct M87's lineage, tracing back the timeline of its mergers. It's like reading the rings of a tree, except here, each ring is measured not in centuries, but in billions of years. And through that light, we learn that beauty can arise not from symmetry, but from endurance. M87's calm appearance is not the absence of struggle, it is the product of survival. Every star within it has witnessed cataclysm. Every orbit has been rewritten by collision. And yet, together, they create something serene. A cosmic sculpture carved not by design, but by time. If you could stand somewhere within M87 and look up, the sky would never be dark. In every direction, stars would burn, soft and golden, stretching endlessly. There would be no single plane of motion, no clear up or down, only the quiet hum of gravity and light. You would be standing in the heart of a galaxy built from the remnants of 1,000 others, surrounded by the soft glow of their combined histories. This is the paradox of M87, that from destruction comes perfection. The collisions that should have torn it apart instead made it whole. Its glow is not just illumination, it is remembrance. A memorial made of starlight, glowing eternally across the depths of space. Invisible and dominant, dark matter surrounds M87 like a vast cocoon. Though we cannot see it, its gravity defines the galaxy's shape, guiding the dance of stars and controlling the rhythm of its jet. For all the brilliance that M87 displays, its glowing core, its radiant halo, its magnificent jet of light, most of what makes it what it is cannot be seen at all. The true bulk of this galaxy is hidden, existing as a vast, invisible structure of matter that neither emits nor absorbs light. Astronomers call it dark matter, though the name is almost poetic, because in truth, it is not dark. It is transparent, intangible, and silent, detectable only through the gravity it exerts on the things we can see. Imagine M87 not as a glowing island in the void, but as the visible peak of an enormous mountain buried beneath a cosmic sea. The starlight we observe is merely the tip, the bright summit. Beneath it lies an unseen foundation of mass that anchors everything else in place. This dark matter halo stretches well beyond the visible edges of the galaxy, farther than even the most distant globular clusters that orbit its core. It may extend for over 1 million light-years, a sphere so immense that it overlaps with the halos of neighboring galaxies in the Virgo Cluster, knitting them all together into a single gravitational web. Without dark matter, M87 could not exist. The speeds of its stars and clusters would fling them outward into space, tearing the galaxy apart. But the hidden halo holds them fast, keeping the system bound. Astronomers discovered this by measuring the motion of stars and globular clusters, noticing that even at extreme distances from the galaxy's center, where visible mass is thin, the stars still move as if something massive were holding them. That something is the unseen hand of dark matter. It's a quiet presence, one that never glows or burns, yet its influence shapes everything. The black hole at M87's center, the colossal M87, may seem like the galaxy's ruler, but even its power pales beside the gravity of the halo. The black hole controls the center. Dark matter controls the whole. It defines the orbits of galaxies within the Virgo Cluster, determines how gas flows through intergalactic space, and even regulates how often galaxies collide. There's a strange harmony to this relationship between light and darkness. The stars are the visible notes, but dark matter is the rhythm beneath them, the silent tempo that gives structure to the cosmic song. Every flicker of light we see from M87 owes its position, its motion, and its balance to that invisible scaffolding. And yet, we still don't know what dark matter truly is. It doesn't behave like normal matter. It doesn't collide, clump, or form stars. It simply exists, passing through galaxies, through planets, even through us, with no sign of interaction except gravity. It's as though the universe has built its grandest structures from shadows. Some theories suggest that dark matter is made of exotic particles, weakly interacting massive particles, or WIMPs, that drift through space in endless abundance. Others imagine ultralight fields or primordial remnants from the earliest seconds of the universe. Whatever the answer, M87 is a perfect case study. A cosmic laboratory where we can see dark matter's effects written across millions of light years, even if we can't see the matter itself. When astronomers map M87 in different wavelengths, radio, infrared, X-ray, they see how the visible galaxy interacts with this hidden halo. The hot gas surrounding M87 doesn't collapse inward because the dark matter's gravity supports it, holding it in a vast, stable equilibrium. The jet that erupts from M87's core flows through the geometry set by this invisible mass, guided by gravitational contours we can only model. It's as though the galaxy is painting over an unseen canvas, every swirl of light following the curvature of an invisible design. If you could somehow see dark matter, M87 would appear far larger, more majestic, and infinitely more complex. Its luminous center would be a tiny flame within a vast, translucent sphere of invisible substance, shimmering with gravitational tension. The stars, clusters, and gas would appear as tiny filaments woven through a dark lattice, a galaxy suspended inside the framework of an unseen architecture. And perhaps that is the most haunting truth of all. The universe we know, the one made of light, is only a fraction of what truly exists. The rest, the structure that holds everything together, lies in silence. Around M87, that silence is immense, ancient, and absolute, the quiet gravity of a dark hand that sculpts the visible universe and asks for nothing in return. Dark matter is not the absence of light, it is the foundation of it. It does not destroy, but sustains, an invisible guardian, keeping galaxies like M87 from unraveling, and reminding us that what is unseen often defines everything we see. Within M87's bounds lies enough matter to seed thousands of smaller galaxies. It's almost a microcosm, a universe inside a universe, complete with its own stars, black holes, and gravitational currents. When we think of galaxies, we often imagine them as members of a vast community, islands of stars scattered across a cosmic ocean. But M87 defies that image. It isn't just a galaxy, it's a world unto itself. Its sheer scale and complexity make it more like a miniature universe, one that contains everything from the tiniest flickering star to the most powerful forces of nature, all bound together by gravity's invisible thread. Inside this single galaxy, there are trillions of stars, each one with the potential to host planets, moons, and perhaps even life. The distances between them are so immense that even at light speed, it would take thousands of years to cross from one side of M87 to the other. Whole civilizations, if they existed within it, could rise and fall without ever glimpsing the galaxy's farthest edges. The vastness is so overwhelming that it blurs the line between the local and the cosmic, as if M87 itself could stand alone as its own self-contained cosmos. At the center of this inner universe sits M87, the supermassive black hole, a gravitational monarch around which everything revolves. It is both the heart and the engine, its pull regulating the motion of stars, the temperature of gas, and even the growth of new structures. From its event horizon, jets of plasma shoot outward across thousands of light years, like arteries pumping energy through the galaxy's vast body. Around it, dense clusters of stars orbit in chaotic elegance, tracing invisible lines of motion through curved space-time. But M87's structure extends far beyond its luminous core. Surrounding it are globular clusters, ancient, spherical swarms of stars, orbiting like tiny galaxies themselves. Each one contains hundreds of thousands of suns, compact and bright, remnants of the earliest epochs of star formation. Beyond them lies an even larger halo of orphaned stars, drifting through the galaxy's outer reaches, no longer bound to any one system. Together, they form layers upon layers, a cosmic nesting doll of structures within structures. Then there is the hot gas, plasma so thin that a single cubic meter might contain only a few atoms, yet so vast that it outweighs all the stars combined. This gas glows in X-rays, forming a diffuse atmosphere that fills the galaxy and connects it to the surrounding Virgo cluster. Within that gaseous halo are ripples, bubbles, and shock fronts, each one a fossil record of ancient outbursts from the central black hole. These waves move through M87 like weather systems in slow motion, shaping the flow of matter across hundreds of thousands of light years. And threaded through all of this is dark matter, invisible, unyielding, the unseen skeleton of M87's cosmic body. It binds everything together, creating the gravitational landscape in which stars and galaxies move. Without it, the galaxy would fly apart. With it, M87 becomes a complete system, balanced, coherent, and breathtakingly complex. If you could observe M87 over billions of years, you'd see it evolve like a living organism. Galaxies would drift inward and be consumed. New stars would flicker to life in bursts of light. Old stars would fade into white dwarfs and neutron stars. Supernovae would bloom like cosmic fireworks, scattering heavy elements that would later form new worlds. Even the central black hole would grow, fed by the endless cycle of creation and destruction. Every process that shapes the universe, from the birth of stars to the death of galaxies, happens within M87's borders. In this sense, M87 is not just a galaxy, it's a model of the cosmos itself. It mirrors the same dynamics that govern the universe on the grandest scale. Gravity weaving order from chaos, light emerging from darkness, matter recycling endlessly through time. It's a fractal of creation, a smaller version of everything we know, a reminder that each galaxy is a reflection of the universe it inhabits. Standing beneath a night sky and imagining M87 is to glimpse the infinite nested within the finite. It's to realize that even within a single galaxy, there are realms so vast they could hold their own histories, their own destinies, their own eternities. M87 is a universe within itself, a self-contained cosmos, alive with motion and mystery, echoing the same patterns that shaped everything, from the smallest atom to the farthest galaxy cluster. And perhaps that is the quiet wonder of it, that inside one galaxy, we can see the reflection of all galaxies, and within one world of stars, we can trace the heartbeat of the universe itself. Many of M87's stars are ancient, older than our Sun by billions of years. Some shine dimly in red hues, their lives fading, their light still crossing space long after their fires have gone out. To look upon M87 is to look deep into time itself. Every shimmer, every faint glimmer of starlight is a message sent from a distant past, a moment that no longer exists. Some of the photons reaching our telescopes tonight left their stars before the Earth had formed, before the sun began to burn, before life stirred in any ocean or sky. They've been traveling ever since, unbroken, uninterrupted, until they finally arrive here, whispering stories of a universe long gone. M87's stars are not young and blue, like those in freshly formed spiral galaxies. They are old, ancient survivors of cosmic epochs when the universe itself was still new. These stars burn with a steady, amber light, their fuel slowly depleting, their brilliance soft and mature. Most are red giants or faint dwarfs, glowing faintly but persistently, the last embers of the galaxy's once vivid youth. Their light, filtered through time and distance, gives M87 its golden hue, the color of memory, of endurance, of stars that have seen too much and endured too long. But not all of them still exist. Many have already died, their light still journeying through space as if unaware of their own extinction. Their remnants drift invisibly, white dwarfs cooling in silence, neutron stars spinning in the dark, black holes merging quietly in hidden corners of the galaxy. And yet, their light remains, the final echo of their existence, carrying the signature of what they once were. If you were to stand on a planet orbiting one of those dying stars, your sky would be filled with the faint glow of others just like it, a field of dim gold and red, stretching endlessly. You'd see no Milky Way-like arms, no bands of dust, only the soft, omnidirectional haze of starlight. And though it might appear serene, you would be standing within an ancient mausoleum of light, a place where nearly every star you see has lived a full life and moved quietly toward its end. Astronomers can read these stellar histories through light itself. Each photon carries information about the star it came from, its temperature, its age, its chemical makeup. When scientists analyze the spectrum of M87's glow, they find signatures of old, metal-poor stars. Stars formed when the universe had fewer heavy elements. This means M87's population is among the oldest in the cosmos. A collection of survivors from the earliest generations of galactic formation. They are cosmic elders, still shining softly after trillions of their younger counterparts have come and gone. And this light, this ancient, persistent radiance, becomes something more than illumination. It is the galaxy's memory. Through it, we see everything that came before. The collisions, the births, the deaths. M87's glow is the sum of every life it has ever contained, a collective echo of countless suns burning across billions of years. Each photon, each flicker, is a fossil, a time capsule drifting through eternity. Even the light we capture now is far from new. It began its journey 53 million years ago, long before humans existed. Dinosaurs had already vanished. Mammals had barely begun to flourish. While our ancestors were still dreams in evolution's future, the light that now touches our telescopes was already en route, silent, patient, unstoppable. In this way, M87 is not merely an object in the sky. It is a time machine. When we look at it, we aren't seeing the galaxy as it is, but as it was. The light we observe is history itself, frozen in transit. The stars that shine for us tonight may already be gone, but their glow persists, carrying on long after their energy has faded. There's a quiet beauty in that thought. that light outlives its source, that the echoes of creation travel on forever, crossing the void long after their makers have fallen silent. In M87, that truth is written across every inch of its glow. It is a galaxy built not just of matter, but of memory. And so, when you see that faint, golden shimmer from Earth, that hazy oval lost among the stars of Virgo, remember this. You're not just looking at a galaxy, you're looking at the afterglow of eternity, light still making its way across the cosmos, carrying with it the final breath of suns that died before our world even began. Every orbit, every swirl of gas, and every echo of light around M87 is part of an invisible symphony, gravity's own music, written in space-time instead of sound. If we could translate the motions around M87's central black hole into sound, it would not be a chaotic roar, but an elegant, resonant melody, a deep, gravitational hum vibrating through the very fabric of space. Each particle of gas, each beam of light, each magnetic ripple moves in rhythm with the immense curvature of space-time, creating harmonics that stretch across thousands of light years. It is a cosmic orchestra without audience, a concert conducted by gravity itself. In the heart of this orchestra, M87 is both composer and conductor. Its 6.5 billion solar mass presence dictates every note and movement. Matter falling inward spirals faster and faster, tracing arcs of motion like the tightening pitch of a violin string. Time slows as it nears the event horizon, stretching the tempo of existence until it nearly stops. Yet to a distant observer, these motions form a steady, enduring rhythm. This music of gravity doesn't exist in sound waves, but in patterns of energy and motion. Gas clouds circling the black hole follow orbits that create beats and pulses as they flare and fade. Magnetic fields twist and release in bursts, the percussive crashes of this cosmic symphony. Even the colossal jet shooting from M87's core has a tempo, flickering and fluctuating in cycles that last years, each change a subtle movement in an ongoing score. When astronomers study M87, they don't hear the music. They see it in data. The waves of light, the shifts in polarization, the rhythm of flares in X-ray and radio wavelengths, all are notes written in the language of physics. Instruments like the Event Horizon Telescope and the Chandra X-ray Observatory record these patterns, translating the invisible vibrations of space-time into a form we can understand. Through their eyes, we glimpse the melody that underlies the chaos, a balance between destruction and harmony, motion and stillness. Even the surrounding stars and globular clusters contribute their quiet accompaniment. As they orbit the galaxy's heart, their collective motion creates a slow, deep tone, a background resonance across millions of years. Their orbits are like the bass notes of this symphony, steady and enduring, while the black hole's activity provides the soaring crescendos of energy and light. What's extraordinary is how stable this song is. Despite the violence at its core, matter colliding at relativistic speeds, magnetic storms twisting space, M87's structure holds firm. The shape of its glowing ring, the direction of its jet, and the rhythm of its outbursts remain remarkably consistent over time. It's as if the galaxy plays from a score written long ago, a symphony so vast that even a single note lasts thousands of human lifetimes. The concept of sound in space might seem strange, but in a way, M87's symphony is sound, not through air, but through the oscillations of space-time itself. Just as a drum's surface vibrates when struck, the very fabric of the universe ripples when massive objects move. Every collision, every flare, every gravitational interaction sends faint gravitational waves cascading outward, carrying the silent music of M87 across the cosmos. If our ears could detect them, they would hear a tone lower than any instrument could play, a deep, steady drone echoing through eternity. Scientists believe these rhythms, encoded in gravitational waves, might one day be detected by future observatories. Each pulse would reveal something new. The mass of the black hole, the density of the gas, the dynamics of the magnetic fields. We would, in essence, be listening to the heartbeat of a galaxy, the steady pulse of gravity that has persisted for billions of years. And perhaps, That is what makes M87 so mesmerizing. It isn't just a place, it's a performance. Every photon, every orbiting star, every ripple of magnetism contributes to a cosmic score that has been playing since before the Earth existed. It is a reminder that the universe, for all its silence, is never truly still. It hums with motion, with rhythm, with the quiet music of gravity weaving light into harmony. To watch M87, then, is to witness a song of creation and endurance, a supermassive symphony echoing across time, a melody written in the curvature of space, played by stars and light, and conducted by the invisible hand of gravity itself. And though we may never hear it with our ears, somewhere deep in our understanding, we feel it, a vibration in the soul that whispers of the grand design that binds us all. Occasionally, M87's jet brightens suddenly, flaring across wavelengths from radio to X-ray. These cosmic tempests are triggered when matter falls too close to the event horizon, feeding the black hole's hunger. In those moments, M87 awakens. Its calm facade ripples with fury as the supermassive black hole draws in surrounding gas and dust, twisting them into spirals of incandescent energy. The galaxy's heart becomes a maelstrom, magnetic fields snapping and reconnecting, shock waves radiating through space, and light bursting forth across the electromagnetic spectrum. What we witness from millions of light years away is the afterglow of a feeding frenzy, a cosmic storm that burns brighter than a billion suns. The flares begin in the accretion disk, the glowing whirlpool of matter orbiting just outside the event horizon. Here, gravity crushes time and space into submission. Temperatures climb into the millions of degrees, and the plasma, rich with magnetic energy, twists violently. When a clump of material plunges inward, it compresses and heats further, releasing a sudden flash of radiation. In seconds, that energy can outshine the rest of the galaxy. And yet, from Earth, the light takes 53 million years to reach us. A delayed echo of an ancient storm, still roaring in the depths of time. These flares are not random. They follow the rhythm of M87's accretion cycles, pulses of feeding and resting that play out over years or decades. Sometimes, the black hole seems quiet, its jet stable and steady. Then, with little warning, it erupts. Astronomers have captured these moments through coordinated observations, using telescopes that span the globe, from radio arrays to space-based X-ray detectors. Together, they reveal the anatomy of a flare, a sudden brightening near the jet's base, followed by a surge of light moving outward along its length. The flare travels like a wave, illuminating the jet from within, before fading back into darkness. At the heart of this process lies magnetism. The black hole itself has no magnetic field, but the plasma swirling around it does. As the disk rotates, it winds these fields tighter and tighter, like a coiled spring. Eventually, the tension becomes too great, and the field lines snap. This magnetic reconnection releases staggering amounts of energy, accelerating charged particles to near the speed of light. The result is a burst of radiation that spans the spectrum, from low-frequency radio waves to searing X-rays and gamma rays. The flares we see from M87 are so powerful that they can affect the galaxy's surroundings. As jets brighten and expand, they push against the interstellar gas, creating shock fronts that ripple outward. These waves heat the cluster's plasma, sculpting cavities and bubbles that can persist for millions of years. It's a feedback loop. The black hole feeds on the galaxy's gas, then returns that energy in colossal outbursts that reshape the environment, regulating the very material it depends upon. To visualize this, imagine a storm brewing over an alien sea. The winds howl, the waves rise, and lightning flashes across the sky. But here, the sea is made of plasma, the wind is magnetic force, and the lightning is light itself. Each flare is a thunderclap in space-time, reverberating through the cosmic void. One of the most famous flares from M87 was recorded in 2005, when the jet's inner regions brightened dramatically. Over a few days, its intensity increased by more than 100-fold, flooding detectors with radiation. Astronomers traced the event to a knot in the jet known as HST-1, a bright feature located thousands of light-years from the core. Somehow, the energy released near the black hole had traveled outward, igniting this distant region. It was as if the galaxy's heart had fired a pulse down the jet, like a heartbeat racing through arteries of light. These events remind us that even across millions of light-years, we are connected to the raw power of the universe. Each photon that reaches our telescopes is a survivor, a traveler that has escaped the gravitational jaws of a black hole to bring us a glimpse of its storm. They are messages from the edge of physics, carrying information about regions where space and time lose their meaning. And yet, there is beauty in that chaos. The flares that blaze from M87's core are not signs of destruction alone. They are signs of balance, the universe's way of releasing energy, of maintaining equilibrium amid extremity. They illuminate not just the sky, but our understanding of how galaxies breathe and evolve. M87's storms are ancient, but not eternal. Each flare fades, each eruption cools, and the galaxy's heart returns to its patient hum. Until, one day, another spark falls too close, and gravity's symphony swells once more, lighting up the void with the echoes of creation and the music of the stars. Near the event horizon of M87, time itself bends. For an outside observer, infalling matter seems to freeze, trapped in endless descent. For that matter, however, the fall is brief, the final plunge into oblivion. This is the strange duality of black holes. They do not just consume matter, they distort reality itself. Around M87, space-time curves so violently that the rules of time break down. From far away, we see the infalling gas and dust circling closer and closer, glowing brighter as it heats. But it never seems to cross the horizon. Instead, it slows, dims, and fades, appearing suspended forever at the edge of existence. Yet for the matter itself, time moves normally. In its own frame, the plunge takes only moments. It falls freely, unaware that to the outside universe, its descent has become eternal. Einstein's theory of general relativity predicted this eerie effect, that gravity is not just a force, but a warping of space and time. The stronger the gravity, the slower time flows. Near M87's event horizon, gravity is so intense that time nearly stops altogether. A clock orbiting close to the black hole would tick hundreds of times slower than one here on Earth. To stand there, if one could, would be to exist at the edge of forever. If you were to fall toward M87, you wouldn't notice time slowing. You wouldn't feel the transition. The universe around you would appear to accelerate instead. Light from distant stars would shift to bluer wavelengths, and the cosmos would seem to speed up, racing forward through millennia in seconds. You would see galaxies age, stars die, and the expansion of the universe itself unfold before your eyes. Then, in your final instant, as you cross the event horizon, time would stop for the rest of the cosmos. But not for you. For you, it would be over, quietly and completely. To distant observers, however, your fall would never finish. They would see you approach the horizon more and more slowly. Your light stretched redder and dimmer until it faded entirely. You would become part of the shadow, frozen in place, your final image smeared across time. This is what astronomers witness when they study the glowing ring around M87. The light they see is not just from gas in motion, but from gas paused, forever trapped in the gravitational lensing of the black hole's edge. The image is both motion and stillness, an eternal present painted across space-time. This interplay between perspectives, the falling matter, and the distant observer, is what makes black holes such haunting symbols of relativity. They remind us that time is not absolute. It depends on where you stand and how fast you move. What is a second near a black hole might be 1,000 years to us. And yet, both experiences are equally true. The universe does not choose one, it holds both at once, harmonizing contradiction into reality. In 2019, when the Event Horizon Telescope captured the first image of M87, it wasn't just a photograph. It was a map of time itself. That glowing ring marks the photon sphere, where light orbits the black hole before escaping outward. Some of those photons circle multiple times before breaking free, carrying with them the imprints of time dilation. The image we see is therefore layered, photons from different moments arriving together, past and present intertwined in a single frame. It's a portrait of space-time folded upon itself. And though the phrase time stops sounds final, it is not truly an end. It is a transformation. The matter falling into M87 doesn't simply vanish. It becomes part of the black hole's energy, its mass, its gravity. It merges with the horizon, contributing to the shape of space-time itself. The information it once carried, the record of what it was, may never escape, but it is not destroyed. It becomes woven into the black hole's fabric, encoded within the event horizon like a cosmic memory. If we could stand far above M87, watching through eons, we would see the galaxy's heart pulsing faintly with the energy of these events, a timeless rhythm of matter falling, time slowing, and light escaping. Each flicker of brightness marks a moment stretched to infinity, a silent echo of the boundary between being and nothingness. And that is perhaps the greatest paradox of all, that in the heart of the universe's most destructive force lies a kind of stillness, not chaos, but silence. Time itself pauses there, as if the cosmos is taking a breath. In that pause, in that infinitesimal moment where everything stops, the universe reveals one of its most profound truths, that endings and beginnings are the same thing, seen from different points of view. M87 teaches us that time is not a single thread, but a tapestry, one that bends, twists, and folds under the weight of gravity. Near its event horizon, that tapestry tightens into stillness, and time, the most human of all experiences, becomes something eternal. In 2025, scientists discovered that M87's magnetic fields sometimes reverse, flipping like a cosmic heartbeat. These polarization flips may explain how jets are launched and how galaxies breathe energy into space. This discovery was more than a technical detail. It was a revelation about how the universe organizes its power, how invisible fields of force guide the flow of light, matter, and energy through the heart of a galaxy. For years, astronomers had watched M87's jet pulse and flare, its energy rising and falling like a living thing. Now, they had found its pulse, a literal heartbeat, marked in the shifting patterns of magnetic polarization. It was as though the black hole itself inhaled and exhaled, breathing magnetism into the surrounding void. Near the event horizon of M87, gravity and magnetism are locked in an eternal struggle. Plasma, a sea of charged particles, swirls around the black hole, dragging magnetic field lines with it. These lines twist, knot, and stretch until they snap and reconnect in powerful bursts, releasing energy that can accelerate matter to nearly the speed of light. Each magnetic reversal is a moment of transformation, when the field reconfigures itself and a surge of energy ripples outward, igniting the jet. In the Event Horizon Telescope's polarized light images, these reversals appear as changes in direction, the light wave's orientation rotating from clockwise to counterclockwise over time. The pattern is rhythmic, almost biological. Every few years, the polarity flips, like the beating of an enormous magnetic heart. The phenomenon is similar, in principle, to the magnetic cycles of our Sun, where magnetic fields reverse every 11 years, fueling solar flares and coronal ejections. But in M87's case, the scale is cosmic. Instead of solar winds, these magnetic storms drive a jet that stretches for 5,000 light-years. To visualize what's happening, imagine a whirlpool of fire, threaded with lines of force you cannot see. Each rotation of plasma winds these lines tighter, until their tension becomes unbearable. Then, in an instant, they snap and realign, flinging energy outward like a whip cracking through space. The result is a flare, a surge of light and motion that races down the jet, heating and energizing the galaxy's surroundings. This magnetic heartbeat may be the mechanism that regulates how M87 interacts with its environment. Each reversal redistributes energy, controlling the balance between inflow and outflow, between feeding and breathing. The black hole consumes matter, but it also gives back through its jet, sending radiation and magnetic turbulence across intergalactic space. Without these reversals, the galaxy might either starve or explode. Instead, the magnetic cycle keeps it in harmony, allowing M87 to sustain its activity for billions of years. The discovery of this rhythm also hints at something deeper, a universal principle that may apply to all galaxies with active cores. Black holes, despite their reputation for destruction, appear to be engines of order. Their magnetic fields act as conductors, channeling chaos into structure. In M87's case, the magnetic flips are like the resetting of a cosmic metronome, keeping time for the entire galaxy. Each pulse sends out waves of energy that stir the surrounding gas, regulate star formation, and shape the evolution of everything within its gravitational domain. From a distance, these reversals are invisible. We can't see the magnetic field lines directly, only their effect on polarized light, the subtle rotation of electromagnetic waves as they pass through the storm. But through these delicate observations, scientists have begun to read the hidden heartbeat of a galaxy. It's a reminder that even in the emptiest regions of space, invisible forces are at work, moving to rhythms older than time itself. If you could stand near the base of M87's jet, an impossible place for any being to survive, you might feel this pulse in the very fabric of space-time. The field lines would shimmer and twist, glowing faintly as charged particles spiraled along them. You'd see bursts of light erupting in sync with the magnetic flip, each one a spark in the galaxy's endless breath. The silence would be absolute, but the energy would be overwhelming, a quiet storm that sustains the cosmic dance. In the end, M87's magnetic heartbeat reminds us that the universe is not static. It is alive with motion and pattern, with cycles and rhythms we are only beginning to perceive. The same physical laws that drive the heartbeat of a star, the rotation of a planet, or even the pulse within us echo in the heart of a galaxy 53 million light-years away. Every few years, as M87's polarity reverses and its jet brightens again, it's as if the universe itself takes a breath, exhaling light, energy, and magnetism into the void. And for a moment, across the immeasurable silence of space, we can almost hear it, the deep, steady thrum of a galaxy's heart, beating in time with the cosmos itself. Light from M87 left before humanity existed, traveling 53 million years to reach us. Every image of its glowing core is a message from deep time, a glimpse of what was, not what is. When we look at M87, we are not seeing the present, we are peering into the past. The light that touches our telescopes tonight began its journey when the world was unrecognizable. 53 million years ago, our planet was warm and green, dominated by early mammals and vast forests. Antarctica was not yet icebound, and the continents were still shifting toward the map we know today. While life was just beginning to diversify on Earth, the light from M87's heart was already on its way, racing endlessly through space, carrying the imprint of that distant moment. Each photon that arrives is a survivor of a journey so long and fragile that it feels almost impossible. These tiny packets of energy were born from the chaotic heart of a galaxy, from stars colliding, from gas heating near the black hole's edge, from jets piercing the interstellar medium. They traveled across intergalactic space, past other galaxies, through the thin cosmic web that connects the universe together. And through all that time, they never slowed, never aged. They simply moved until, one day, they struck the mirror of a telescope here on Earth, ending a voyage that began before our species existed. To think about this is to feel both small and infinite. Every image we take of M87 is a kind of time machine, a frozen postcard from an era when humanity was a dream yet to come. What we call now is always built on the light of what has already happened. The glowing halo we see, the jets stretching through the void, even the shadow of the black hole itself, all of it belongs to a version of the universe that has already changed. Somewhere, right now, M87 looks different. Its stars have moved, its core has shifted, its light continues onward toward galaxies yet unborn. We can never see it as it truly is, only as it was. This is one of astronomy's quiet paradoxes. Everything we see is history. The farther we look, the older the story becomes. To gaze into space is to look into time, to see the universe unfolding in reverse. M87, glowing faintly in Virgo, is not just a distant object, it is a memory still shining. Its light began when Earth was young, and it will continue long after our planet is gone. Imagine holding a photograph taken long before you were born, a picture so old that the people in it no longer exist. That is what it means to observe M87. We are receiving photons that carry the memory of stars that may already have died, of gas that has long since scattered, of a jet that has changed shape over eons. The light does not lie, but it tells only part of the story, the part preserved in transit, untouched by time's decay. And yet, within that ancient light, there is a kind of immortality. For the photons that left M87 53 million years ago are still new when they arrive here. They have not aged in their journey. To them, no time has passed. In the strange physics of light, time stands still. While we measure their travel in millions of years, the photons themselves experience none of it. They are timeless messengers, bridging epochs with a single leap. When we captured the first image of M87's black hole, we weren't just looking across distance, we were looking across time. The orange ring, glowing like an ember, is an echo of what the galaxy's heart looked like when early primates walked on Earth. The light we see now carries the memory of magnetic storms, collapsing stars, and swirling gas that have long since changed, but whose stories still travel onward. Written in the language of photons. It's humbling to realize that even as we look into the past, our own light is beginning its journey outward. The faint radio signals, the glimmers of city lights, the glow of our sun, all of it is already traveling into the universe, destined to become someone else's ancient light millions of years from now. Perhaps, one day, another civilization will look back across time and see the ghost of our world, just as we see M87 now, a faint, fragile echo of a place that once was. In that sense, light is memory made eternal. It preserves what time erases. It reminds us that the universe, for all its vastness, is one long conversation between past and present, a dialogue carried by photons through the silence of space. And so, when we look at M87, we are not just observers, we are participants in an ancient exchange, witnesses to light that has outlived stars, galaxies, and even worlds. The glow we see tonight is not just illumination, it is history itself, whispering across the ages, reminding us that in the great stillness of the cosmos, M87 dominates the Virgo Cluster, but it's surrounded by smaller companions, galaxies like NGC 4000, 478, and NGC 4000, 476, each caught in the slow pull of its immense gravity well. This is not a solitary giant, but a monarch presiding over a court of galaxies, each moving in slow, deliberate orbits through the dense heart of the Virgo Cluster. Around M87, the sky would not be dark. The surrounding space is littered with thousands of glowing shapes, spirals, ellipticals, and irregulars, each one a cosmic city of stars. Together, they form a gravitational metropolis, a community of galaxies bound by the invisible threads of gravity, all swaying gently to the same cosmic rhythm. At the cluster's center, M87 reigns supreme. Its gravity extends like a web, influencing objects millions of light years away. The smaller galaxies near it, NGC 4000, 478, NGC 4000, 476, and countless others, orbit in elongated paths, their motions dictated by M87's colossal mass. Over billions of years, some will spiral inward, torn apart by tidal forces and slowly absorbed into the giant's expanding halo. Others will remain at the edges, forever circling like moons caught between freedom and capture. To an observer within this cluster, space would appear alive with motion. Entire galaxies glide silently through the void, their paths curving toward M87's gravitational center. Occasionally, two galaxies will pass close enough to disturb each other, their stars tugged into long, luminous streams. Clouds of gas and dust, stripped away by gravity, trail behind like cosmic smoke. These interactions are slow by human standards, unfolding over hundreds of millions of years, but together they create the ever-changing tapestry of the Virgo cluster. At the scale of the cluster, M87's dominance becomes clear. It is not just large, it is the gravitational anchor of an empire. The hot gas that fills the Virgo cluster, glowing faintly in X-rays, is held in place by M87's pull. This gas forms a vast halo around the galaxy, extending for millions of light years, through which the smaller galaxies drift like fish in a glowing sea. The gas is so hot, tens of millions of degrees, that it emits X-rays, revealing the immense pressure and energy locked within this region of space. But M87 is not alone in shaping this cluster. Other giants, like M49 and M86, play their parts, pulling and pushing in a gravitational ballet. Yet M87 stands apart. It sits at the cluster's true center, not by coincidence, but by inevitability. Over billions of years, as galaxies merge and shift, the most massive ones naturally drift toward the core, where their combined gravity settles the cluster into balance. M87, having consumed many of its neighbors, has become the ultimate anchor, the point around which the entire Virgo cluster orbits in slow, silent harmony. Each of M87's smaller companions tells a different story. NGC 4478, for example, is a small elliptical galaxy, stripped of gas and star formation by its proximity to the giant. It shines faintly, a remnant of what it once was before M87's gravity began to unmake it. NGC 4476, slightly farther out, shows scars of tidal disruption, a ghostly reminder that no galaxy escapes M87's influence for long. These smaller systems are, in a sense, satellites in the process of being consumed, future ingredients in M87's endless growth. The space between galaxies here is not empty. Streams of stars, remnants of past mergers, stretch across the cluster like threads of starlight. These faint, diffuse bridges connect galaxies that once collided or passed close by. Astronomers can detect them in deep images, revealing a hidden network of stellar debris that ties the cluster together. This starlight is ancient, drifting freely between galaxies, glowing softly in the cluster's dim background. If you could stand on a world within one of these smaller galaxies, the night sky would be astonishing. M87 would dominate the heavens, a vast, glowing ellipse brighter than any moon, filling a portion of the sky with golden light. Its core would shimmer with the intensity of 1,000 billion stars, while its faint outer halo would stretch outward, blending into the darkness of intergalactic space. It would be a constant reminder of your galaxy's place in the hierarchy, a neighbor so large and powerful that its presence shapes the very fabric of your sky. And so, M87's neighborhood is not quiet. It is alive, dynamic, evolving. Galaxies drift and collide, stars are stripped and shared, and energy ripples through the cluster like waves in an invisible sea. From Earth, we see only the still image, a serene, hazy glow in Virgo. But in reality, this is a realm of perpetual motion, a community of galaxies bound together by one colossal heart. Over cosmic time, that neighborhood will change. One by one, the smaller galaxies will be drawn in, their light merging with M87's own, their histories absorbed into its vast halo. The cluster will grow quieter, simpler, smoother, until, perhaps, only one great galaxy remains, surrounded by the fading ghosts of those it once called neighbors. In the universe's grand design, M87's neighborhood is both a testament to creation and a prelude to absorption, a living reminder that gravity binds all things together, until, in the end, everything becomes one. The gas swirling into M87 is devoured at a rate of roughly 90 Earth masses per day, yet only a fraction becomes energy. The rest disappears beyond the horizon, lost forever to time. At the heart of M87, this feeding is a ritual older than stars themselves, a dance of destruction that fuels creation. Matter drawn inward by gravity spirals into the accretion disk, heating to millions of degrees as it approaches the point of no return. Every particle collides, twists, and accelerates, releasing bursts of radiation before crossing the horizon and vanishing into silence. To an outside observer, the infall slows as time stretches, but to the matter itself, the fall is swift, a final, irreversible dive into darkness. 90 Earths a day. The number is staggering, yet it's only a whisper compared to the black hole's hunger. Even with that constant consumption, M87 barely grows. The sheer scale of its mass, 6.5 billion times that of the Sun, makes these meals almost meaningless. It's like adding grains of sand to a mountain. The energy unleashed in the process, however, is extraordinary. As matter swirls inward, magnetic forces and friction convert a portion of that mass into radiation, producing light and heat that can outshine entire galaxies. But the black hole is a selective diner. Most of what it consumes never becomes light. Only a few % of the infalling material is transformed into energy. The rest crosses the event horizon, erased from the observable universe. Once past that boundary, information ceases to exist in any recognizable form. The particles, the atoms, the energy, all of it is compressed into the singularity, a region where space and time fold into one another, and the laws of physics we know can no longer describe reality. Around this dark heart, the accretion disk burns like a celestial furnace. It's not a smooth, steady flow, but a turbulent sea of plasma, constantly shifting and reshaping itself. Magnetic fields arc and twist, forming filaments that connect the disk to the galaxy's jet. In some regions, the gas becomes so hot that it emits X-rays. In others, it cools just enough to radiate invisible and infrared light. This glowing storm is what the Event Horizon Telescope captured, the orange ring surrounding M87's shadow, a fiery halo marking the boundary between existence and oblivion. Every flare, every pulse of brightness we observe from M87 marks a moment of feeding, a brief flash of energy before the material is swallowed. The process is chaotic yet elegant, a cosmic engine running with perfect efficiency at the edge of the impossible. Some of the gas doesn't fall inward at all. Instead, it's caught by the black hole's magnetic fields and flung outward, fueling the enormous jet that stretches across space. The black hole devours, but it also creates, turning infalling matter into motion, light, and structure. It's easy to think of this feeding as violent, but it's also necessary. These outbursts regulate the galaxy around it, shaping its temperature, density, and evolution. Without the black hole's appetite, M87's central regions might grow cold and dormant, star formation would run rampant, and the balance between matter and energy would collapse. The black hole's feast, then, is not destruction, it's maintenance. A form of equilibrium that sustains the galaxy over cosmic timescales. If we could hover near the accretion disk, far enough to survive, but close enough to see, we would witness one of the most magnificent sights in the universe. Rivers of plasma, glowing gold and blue, swirling in vast arcs as they spiral downward. Jets of energy erupting from the poles, streaking into the darkness. Space itself would shimmer with distortion as light bent around the gravity well, and in the center, a shadow, perfectly round, perfectly still, marking the mouth of eternity. In that moment, we might realize that feeding is not an act of destruction, but of transformation. The black hole doesn't annihilate what it consumes. It recycles it into the architecture of the universe. The energy released in these moments travels outward, influencing the birth of stars, the temperature of gas, and even the shape of galaxies millions of light years away. The feast is endless, but it is also creative. M87 is both a devourer and a giver, a paradox of cosmic proportions. Every second, it consumes, and in that consumption, it illuminates. It is gravity's greatest masterpiece, a process that takes what falls inward and turns it into the light that guides us across the darkness. And though most of what it eats is lost forever, the echoes of that feast, the light, the energy, the motion, ripple outward through space and time, ensuring that even in the act of consumption, the universe continues to create. The energy released by M87's jet sculpts its surrounding cluster. X-ray observations reveal vast cavities in the hot gas, as if the black hole were exhaling across millions of light years. This is not weather as we know it, not clouds or storms in air and water, but weather on a cosmic scale, where the elements are plasma, magnetic fields, and gravity. Around M87, this cosmic weather shapes entire galaxies, rearranging the matter between them and influencing how stars are born, live, and die. The black hole's jet acts like a celestial wind, pushing and heating gas in every direction. The result is a dynamic environment, alive with turbulence and motion, a galaxy that doesn't just sit silently in space, but breathes energy into the cosmos around it. Through the eyes of the Chandra X-ray Observatory, astronomers have seen the imprint of this breath. The images reveal enormous bubbles and ripples expanding outward from M87's center, colossal voids in the hot, X-ray emitting gas that fills the Virgo cluster. Each cavity is a record of an ancient outburst, where the black hole's jet injected energy into its surroundings. These cavities are vast, tens of thousands of light years across, and they rise through the cluster's gas like bubbles in a boiling pot. Each one marks a heartbeat of activity from the galaxy's core, a pulse of power that keeps the surrounding medium in motion. The process begins when M87's jet erupts with energy. The outflow of plasma, traveling at near light speed, punches into the surrounding gas, displacing it. The shock waves from this impact heat the gas to tens of millions of degrees, preventing it from cooling and collapsing into new stars. Over time, these shock fronts travel outward, their energy diffusing into the cluster. It's a feedback loop. The black hole feeds, releases energy, stirs the environment, and then, by heating the gas, controls how much new material can fall back in. The galaxy's growth and the black hole's appetite are thus locked in a delicate equilibrium. Astronomers call this active galactic feedback, but that term hardly captures its majesty. It's more like a weather system that spans galaxies, a cosmic storm driven by magnetism and gravity. The cavities, the shock waves, the slow rise of plasma bubbles. These are the atmospheric currents of a galaxy cluster. Just as wind patterns on Earth distribute heat and shape climates, these colossal flows redistribute energy throughout intergalactic space. Without them, the central regions of the Virgo cluster would cool and collapse rapidly, igniting bursts of star formation that would change the cluster's entire balance. In essence, M87's jet acts like a thermostat, regulating its environment. When the gas grows too cool, material begins to drift inward, feeding the black hole. The resulting accretion flares power new jets, which heat the gas again, halting further infall. It's a self-sustaining cycle, a form of galactic homeostasis that has likely continued for billions of years. This relationship ensures that both the black hole and the cluster remain stable over cosmic timescales. If you could witness it from within, the scene would be breathtaking. You'd see immense filaments of glowing gas stretching for millions of light years, rippling and curling under the pressure of unseen forces. The black hole's jet would lance through the void like a blade of light, its edges shimmering with radiation. Around it, magnetic storms would twist and pulse, painting invisible patterns into the hot plasma. The cavities, these ghostly hollows in the X-ray sky, would drift upward like rising smoke, carrying with them the memory of the black hole's last eruption. Each bubble that rises from M87's core carries enough energy to power thousands of galaxies. And yet, it's released not in explosions but in steady, rhythmic exhalations. This quiet violence maintains the galaxy's balance, feeding the cluster's evolution like the heartbeat of a living organism. The energy radiates outward, but its effects ripple back inward, regulating the rate of star formation, shaping magnetic fields, and defining the flow of matter for millions of light years in every direction. It's poetic to think of a galaxy having weather, wind and storms and breath, but on the grandest scales, that's exactly what happens. M87's black hole is both the storm and the calm, the destroyer and the regulator. It inhales matter and exhales energy, sculpting a world of plasma seas and invisible tides. And all of it, every bubble, every ripple, every wave of heat, is part of a conversation between the smallest and largest forces in the universe. The microscopic dance of particles near the event horizon becomes the driving force of structures that span millions of light years. From chaos comes order, from violence, balance. When we observe these vast cavities through our telescopes, we are, in a way, watching the weather report of a galaxy cluster. Storms that last eons, winds that move at the speed of light, and a black hole at the center, quietly breathing life and order into the cosmos. If M87 replaced our Milky Way, its outer halo would engulf nearby galaxies, Andromeda, Triangulum, even the Magellanic Clouds, all swallowed into one glowing mass. It's difficult to comprehend a structure so vast that it could consume our entire local group of galaxies and still stretch beyond. M87 isn't just big, it's beyond scale, an entity that defies the boundaries of imagination. Our Milky Way, with its graceful spiral arms and 200 billion stars, feels grand enough. But compared to M87, it's little more than a bright speck, a single note in an endless cosmic symphony. If M87 stood in the Milky Way's place, its faint outer halo would reach far past the orbit of Andromeda, filling the night sky with soft, golden light that never fades. To an observer on Earth, had Earth survived such a cosmic reshaping, the night sky would be transformed into a sea of light. Instead of a dark expanse sprinkled with distant stars, we would live under a constant, glowing veil. The galaxy's core, with its supermassive black hole, would dominate the heavens, a luminous heart pulsing at the center of everything. It would appear brighter than any star, bathing the sky in perpetual twilight. The concept of a night would vanish. The horizon would be washed in a soft radiance that blurred the line between day and darkness. M87's scale challenges not just our senses, but our understanding of what a galaxy can be. Its stellar population is more than 10 times greater than our own, and its diameter spans nearly 500,000 light-years. The Milky Way, in contrast, is about 1/5 that size. The vast halo surrounding M87 extends so far into space that defining where the galaxy ends becomes meaningless. Even at its outermost edges, stars drift within its gravitational domain, faint traces of countless galaxies it has consumed over billions of years. If Andromeda and the Milky Way were merged into one, the result would still be smaller than M87. It's not just larger by quantity, but fundamentally different in nature. The Milky Way is structured, a disk with arms and a central bulge, while M87 is a sphere of stars, smooth and nearly featureless. It's the end state of galactic evolution, the product of eons of collisions and mergers that have erased all trace of the delicate spiral patterns that once were. What remains is the essence of a galaxy, pure mass, light, and gravity, stripped of structure but filled with memory. If we could watch from afar as M87 took the Milky Way's place, the nearby sky would shimmer with distortions. The gravitational pull of such a giant would reshape the orbits of every planet, every star, every cloud of gas within reach. The Andromeda Galaxy, once destined to collide with us in 4 billion years, would already lie deep within M87's halo, torn apart and stretched into streams of light. The Magellanic Clouds, those small satellites of our home, would dissolve instantly, their stars scattered into the halo like glitter in the void. Perspective gives meaning to scale, but M87 defies both. Numbers fail, comparisons collapse. To speak of M87 in human terms is to speak of infinity with finite words. It forces us to recognize that our galaxy and by extension, ourselves, are small, fleeting structures in a cosmos that builds giants without effort. And yet, there is a strange comfort in that. M87 may be enormous, but it obeys the same laws as the Milky Way. The same gravity that binds its trillion stars is the gravity that holds us to Earth. The same light that shines from its core is made of the same photons that warm our world. The scale is incomprehensible, but the pattern is universal. The vast and the minute are woven from the same fabric, following the same rules, shaped by the same forces. If M87 replaced our galaxy, the sky would no longer be a place of mystery and darkness, but of overwhelming presence, a reminder not of isolation, but of connection. Every star would glow brighter, every horizon would hum with light, and yet the quiet truth of our smallness would remain unchanged. We would still be observers in an endless sea, still asking the same questions, still staring upward, trying to understand where we fit within the grand design. Perspective, after all, is the universe's most humbling gift. To see M87 is to confront the limits of imagination, to realize that even the grandest things we know are but whispers in a far greater song. And though it dwarfs everything we can comprehend, M87 also reflects something familiar. The same forces, the same physics, the same beauty that govern the stars above our own world. It is vast beyond reason, and yet, somehow, it is also home. M87 is more than an object of study. It's a proving ground for physics. Its stability confirms general relativity on scales far beyond Earth's tests, proving that Einstein's equations still hold even at the edge of infinity. For over a century, general relativity has been our map to understanding the universe's architecture. It describes how space curves around mass, how time bends near gravity, and how the invisible framework of the cosmos guides everything from the fall of an apple to the orbit of galaxies. But never before had it been tested so close to the edge of a supermassive black hole, a place where gravity's pull becomes almost infinite, and where theory itself could begin to unravel. Then came M87. When the Event Horizon Telescope captured the first image of M87's black hole in 2019, it wasn't just a photograph. It was a test of the universe's most elegant equation, E equals mc squared, and its larger, geometric sibling, Einstein's field equations. That glowing ring of fire, encircling the darkness at its center, was exactly what general relativity predicted. Every curve of light, every flicker of brightness matched the equations with breathtaking precision. The image became a universal signature, proof that gravity behaves the same way near a 6 billion solar mass monster as it does here on Earth. The beauty of that discovery lies in its simplicity. Einstein's equations, written in 1915 with chalk and paper, still describe a galaxy 53 million light-years away with uncanny accuracy. The structure of the ring, the way it glows brighter on one side, the way light bends around the shadow, all perfectly align with the mathematics of curved space-time. Even the polarization of light, the orientation of its waves, reveals the fingerprints of magnetism and gravity working together in a cosmic ballet that Einstein himself could only have imagined. But M87 does more than confirm what we already know. It challenges us to go further. Deep in its core lies a region where our understanding ends, the singularity, a point where density becomes infinite and where relativity can no longer speak. Here, quantum mechanics and gravity collide, and their languages break down. M87 is the universe's blackboard, daring us to complete the equation, to find a theory that unites the very large with the very small. Every photon that escapes its grip carries data about this frontier, whispering secrets about how reality itself is woven. Even the behavior of stars and gas around M87 testifies to the truth of general relativity. Astronomers have measured the orbits of stars thousands of light-years from the core, their speeds governed perfectly by the predictions of Einstein's curvature. The galaxy's jet, propelled by twisted magnetic fields and relativistic motion, displays the time dilation and energy transformations that relativity foretold. Nothing drifts out of order. Nothing contradicts the geometry that Einstein drew. Yet there's an eerie irony here. M87, so immense and ancient, proves that our greatest human theory, something born from fragile brains on a small planet, holds true across unimaginable scales. From the fall of a pebble to the motion of a black hole, the same laws apply. This symmetry, this consistency, is what gives the universe its harmony. Even at the very edge of existence, where light itself struggles to escape, the cosmos plays by the same rules that govern a pendulum or a planet's orbit. But physicists know that relativity, perfect as it seems, cannot be the whole story. M87's black hole is also a question, a portal to the unknown. The singularity hidden within is a mathematical impossibility, a place where time stops and space ceases to have meaning. If we could look beyond that veil, we might see the next evolution of physics. Quantum gravity, the unification of all forces. For now, we can only listen to the light that escapes, tracing its arcs across the void, reading the faint echoes of that mystery. It's humbling to think that a galaxy so far away, so vast and ancient, is helping us understand the laws that shape everything, from atoms to stars. M87 isn't just a subject in a telescope, it's a mirror for our own curiosity. It reflects back the questions we ask about existence itself. Why do the laws of nature remain so consistent? How deep does the order go? And what happens when even order breaks? In its quiet enormity, M87 stands as proof that the universe can be known. That human thought can reach across millions of light years and still grasp the truth of gravity. It is, in essence, the experiment of eternity, a galaxy that demonstrates how the same mathematics that guide an apple's fall describe the dance of galaxies, black holes, and time itself. And though M87 confirms what we know, it also reminds us of how much we don't. Somewhere within that shadow, beyond where equations can follow, lies the next great discovery, waiting patiently, as it always has, for us to find the courage to understand it. Inside M87's outer halo, the night would never truly be dark. A soft glow would bathe everything, starlight scattered from every direction, eternal twilight stretching for eternity. Imagine standing on a lonely world adrift in M87's vast outer halo. The stars are everywhere, yet nowhere bright enough to cast shadows. There is no Milky Way-like band across the sky, no sharp constellations, only a smooth, omnipresent radiance, a faint golden haze that seems to come from all directions at once. It is a light both comforting and infinite, the glow of uncountable suns whose combined brilliance softens the darkness rather than banishing it. Here, the concept of night loses meaning. Every moment is a gentle dusk that never ends. This is the quiet between stars, a place so far from any one source of light that all illumination blends into one continuous shimmer. The stars here are ancient, most of them red giants nearing the ends of their lives. They burn coolly, radiating a soft, steady warmth. Their light mingles in the thin intergalactic medium, scattered by the faint dust and gas that still drift through M87's outskirts. What results is not brightness, but serenity, a cosmic glow that feels like memory itself, light lingering long after its sources have faded. The distances between stars in this region are immense. In the Milky Way, neighboring stars may be a few light years apart, but here, in M87's outer halo, the gaps stretch for hundreds or even thousands of light years. A traveler would drift for eons between one faint sun and the next. The silence would be absolute. No winds, no radiation storms, no nearby stars to flood the void with heat or motion. It is as if the galaxy breathes out here, the pulse of creation slowing to a quiet, endless calm. And yet, even in this silence, there is motion. Every star, every cluster, every stray particle of dust still feels the pull of M87's gravity. The entire halo orbits in slow, majestic arcs around the galactic center. The motion is almost imperceptible, so slow that it would take hundreds of millions of years to complete a single orbit. But it is there, steady and eternal. The outer stars move as part of a collective, a symphony played at the edge of perception. Gravity conducts the music, Light provides the melody. The halo itself is not truly empty. It's filled with faint streams of stars, remnants of smaller galaxies that M87 absorbed long ago. These streams form delicate ribbons of light, like trails of smoke from long-vanished fires. They wind and twist through the halo, their paths marking the ancient mergers that built M87 into the colossus it is today. Astronomers have traced these ghostly threads through deep imaging, revealing the scars of past collisions etched faintly across the galaxy's periphery. Each star within them is a relic, an immigrant from a galaxy that no longer exists, now bound forever to the giant that devoured it. If one could look out from within this region, the heart of M87 would hang like a distant ember, a golden sphere tens of thousands of light-years wide, glowing against the velvet backdrop. The black hole's jet, invisible to the human eye, would slice through the void in radio and X-ray wavelengths, unseen but omnipresent, its energy shaping the galaxy's structure even out here. The halo's faint starlight would merge with that central brilliance, creating the illusion that the entire sky was softly alive. It's strange to think that in such stillness, creation is still at work. The stars here may be ancient, but they continue to evolve, cooling, dimming, and eventually collapsing into white dwarfs. Some orbit in pairs, destined to spiral together and merge, releasing brief flashes of light before fading into darkness. Others wander alone, their light traveling endlessly outward, perhaps never reaching another world or eye to witness it. Yet collectively, their glow endures, a chorus of quiet stars singing into the dark. The outer halo of M87 is where the galaxy becomes eternal. Its core burns with activity, jets, storms, and gravity's fierce pull. But out here, those forces are distant whispers. This is the galaxy's horizon of peace, the border between something and nothing, where light and silence coexist. If you stood there and looked outward, beyond the halo, you would see intergalactic space stretching endlessly, the faint spark of other galaxies scattered across infinity. Behind you, the golden glow of M87. Before you, the cold darkness of the universe. You would stand between two eternities, the living light of the galaxy behind and the infinite night beyond. And in that moment, perhaps you would feel what M87 truly represents: the unity of stillness and motion, of light and shadow, of creation and decay. The quiet between stars is not emptiness, it is the afterglow of everything that has ever been, the soft hum of the cosmos continuing long after the song itself has ended. When scientists talk about size, they realize that M87 challenges the very definition. Its outer light fades so slowly that, by some measures, the galaxy could extend nearly 1 million light-years across. The question of where M87 ends is one that has no clear answer, because, in truth, it may not end at all. Unlike a spiral galaxy, which has distinct arms and a visible disk, M87's structure is a vast, diffuse sphere of starlight that gently merges with the intergalactic medium. There's no sharp border, no clear edge, where one can say, this is the galaxy and that is space. Instead, its brightness simply diminishes, slowly, gracefully, fading into the faint glow of the surrounding cluster. It's as if M87 dissolves into the universe itself, its boundaries blurred by time and gravity. Astronomers define the size of a galaxy in several ways: by its visible light, by its mass, or by the region where its gravity dominates. For the Milky Way, those numbers roughly agree. For M87, they diverge wildly. If you measure the region of intense starlight, you get a diameter of about 250,000 light-years. But if you include the faint halo, the barely perceptible wash of ancient stars and stellar debris, the galaxy could stretch 4 times farther. And if you measure its gravitational reach, encompassing every object bound to it, the number grows to nearly 1 million light-years across. That's 10 times the size of our Milky Way and large enough to engulf the entire local group of galaxies, including Andromeda and its companions. This blurring of boundaries poses an almost philosophical dilemma. What does it mean to say something is part of M87? A lone star drifting 500,000 light-years from the center might still be gravitationally bound to the galaxy. But is it truly inside the galaxy, or merely in its influence? The same question applies to the faint globular clusters that orbit far beyond the visible limits, some moving so slowly that their orbits take longer than the age of humanity itself. M87's size, it seems, depends on how one defines belonging in a universe without walls. There's a beauty to that ambiguity. It reminds us that cosmic structures are not tidy or finite. They are gradients, transitions between states, between light and shadow, between something and nothing. M87, in this sense, is not an object, but an ecosystem. Its stars, clusters, gas, and dark matter blend together in a seamless continuum, each contributing to the galaxy's shape, but none marking its boundary. It's a reminder that in nature, definitions often fail where scale overwhelms imagination. From Earth, when astronomers measure M87's faintest light, they're looking at brightness levels barely above the background of space itself, a whisper of photons that could easily be lost in the noise. The galaxy's outskirts are so diffuse that even the most sensitive instruments struggle to detect them. Yet those faint glows are important. They tell the story of M87's violent past, of mergers and tidal interactions that scattered stars into the halo. The farther we trace that light, the more we glimpse the history written in its distribution. And then there's the question of dark matter, the invisible component that makes up most of M87's true mass. We cannot see it, but its gravity defines the galaxy's structure. If we include the reach of that dark matter halo, the unseen hand holding the galaxy together, then M87's influence stretches farther still, perhaps over 2 million light-years. Beyond that range, the Virgo Cluster's collective gravity begins to dominate, merging M87's domain with the larger cosmic web. In the end, the question, how big is M87, becomes less about numbers and more about perspective. To the human mind, size implies something we can measure and contain, but M87 defies containment. It exists on a continuum that blurs the line between galaxy, cluster, and universe. It's not simply an island in space, it's part of a larger current, flowing seamlessly into the cosmic sea. If you could stand on a world within its outer halo and look toward its center, you'd see a golden sphere filling much of the sky, fading imperceptibly into the black. You wouldn't know where the galaxy stopped, because it never truly would. Its light would just thin, star by star, until it blended into the background of creation. Perhaps that's the lesson M87 teaches us. That big enough is not a limit, but a perspective. The universe doesn't draw borders, it draws gradients. M87 is both a galaxy and a bridge, a structure so vast that it erases the distinction between itself and the cosmos that holds it. Its edges are not lines but horizons, where starlight meets eternity and the concept of size becomes as infinite as the space that contains it. Even as other galaxies drift away due to cosmic expansion, M87's immense gravity ensures that its cluster will remain bound together for trillions of years, one of the last lights to shine in a fading universe. In the grand timeline of the cosmos, galaxies are like candles, brilliant for a time, but destined to fade. The universe itself is expanding, stretching space faster and faster, carrying galaxies away from one another like leaves on an ever-widening river. Someday, countless galaxies that we can see now will drift so far that their light will never reach us again. The night sky, once filled with billions of distant glimmers, will grow emptier with every passing eon. Yet in the midst of that growing solitude, M87 will endure, a bastion of light and gravity holding firm against the tides of eternity. This endurance is the gift of its mass. M87 anchors the Virgo Cluster, a gravitational fortress containing thousands of galaxies. While cosmic expansion tugs at everything, local gravity still wins in smaller regions. The galaxies of the Virgo Cluster, bound together by M87's enormous gravity, will never drift apart. Instead, over unimaginable spans of time, they'll merge, one by one, into a single colossal galaxy. The result will be something even grander than M87 itself. A super-elliptical, trillions of stars strong, glowing faintly at the end of cosmic time. Long after the Milky Way and Andromeda have merged and dimmed, long after the nearby clusters have slipped beyond the cosmic horizon, M87 will still shine. It will become a beacon in an increasingly empty universe, one of the final refuges of light in a cosmos that is slowly growing cold and dark. Trillions of years from now, when the last stars in smaller galaxies have burned out, the immense reserves of gas and stellar remnants within M87's core will continue to ignite new suns. Even as entropy spreads, this galactic heart will keep beating. But nothing lasts forever. Eventually, even M87 stars will die, one by one. The brightest blue giants will vanish first, followed by the long-lived red dwarfs, whose faint light could persist for quadrillions of years. When those final embers fade, the galaxy will still not be gone, it will simply change. Its stars will become white dwarfs, neutron stars, and black holes, glowing faintly or not at all. The galaxy's supermassive black hole, M87, will continue to anchor the cluster's remains, feeding occasionally on stray matter and emitting the last whispers of radiation into the cold. By then, the universe around it will be dark. The cosmic microwave background, the afterglow of the Big Bang, will have stretched into wavelengths so long that it becomes undetectable. The stars of distant clusters will have vanished beyond the horizon of space and time. To any beings that might exist in that future, M87 will appear as a rare island of light in an endless ocean of black. It will be both a relic and a sanctuary, a symbol of what once was. And perhaps that's what makes M87 so extraordinary. It is not just a galaxy of the present, it is a survivor of the future. It reminds us that even as the universe trends toward isolation and silence, there will remain pockets of defiance, places where gravity's embrace outlasts expansion's reach. Within M87's vast core, future civilizations, if they arise, might still see starlight, still feel warmth, still wonder about the origins of everything, long after the rest of the cosmos has fallen dark. In that far-off age, when galaxies no longer collide and the stars no longer burn, M87 will be a memory of creation, a faint, enduring ember in the universe's final night. Its light, dim but steady, will carry the history of everything that came before: the merging of galaxies, the birth and death of stars, the formation of black holes, and the silent passing of time itself. Even as eternity unfolds, M87 will stand as one of the last storytellers of the cosmos, a beacon glowing faintly in the infinite dark, preserving the memory of a universe that once was vibrant, young, and full of light. If you could float inside M87, you'd see a sky dense with stars, tens of thousands brighter than Sirius, surrounded by the faint haze of unending starlight. Darkness would be rare. The sky of M87 would be unlike anything we could imagine from Earth. Here, in the Milky Way, our nights are vast and quiet, stars scattered sparsely across a canvas of black. But within M87, especially near its core, the concept of night would almost vanish entirely. Every direction you looked, you'd see the soft radiance of a trillion suns. The sky would shimmer like liquid gold, each star bleeding faint light into the next, until the whole expanse glowed with a steady brilliance. You might find it overwhelming at first, not a sky of points, but of presence. There would be no constellations, no familiar shapes or gaps of darkness to separate one star from another. The light would merge seamlessly, like the reflection of dawn on still water. Shadows, if they existed at all, would be soft and fleeting, erased almost instantly by the collective glow of so many stars. Closer to the galactic heart, the brilliance would intensify. The density of stars there is thousands of times greater than in our region of the Milky Way. The night sky would be an ocean of light, not white, but tinged with amber and rose, the cumulative color of countless old, red stars. The sheer radiance would be enough to illuminate entire worlds, even without a nearby sun. A planet orbiting one of these inner stars might never know darkness. Its skies would remain lit, softly and eternally, by the glow of neighboring suns. In such a place, the heavens would move slowly. Stars that seem fixed for us would drift perceptibly across the horizon over centuries or millennia. Stellar encounters would be more common. Some stars passing close enough to disrupt planetary orbits or ignite temporary bursts of light as gravitational tides tore at their edges. It would be a restless beauty, serene from afar, but alive with motion and danger beneath the calm. From within M87's outer regions, the view would be different, more diffuse, quieter, but still glowing. You'd look toward the galactic center and see a colossal sphere of light dominating the sky, brighter than 1,000 full moons. Its edges would fade into an unbroken haze of starlight, a reminder of the galaxy's immense scale. In the opposite direction, the stars would thin, but never fully disappear. Even in the farthest reaches of M87's halo, the combined glow of the galaxy's core would wash faintly across the void, an eternal twilight that never fades. And then, hidden at the center of all that brilliance, would be M87's heart, the supermassive black hole, M87. You wouldn't see it directly, of course. Its gravity would bend the light around it, creating strange distortions, lensing the stars into rings and arcs. If you drifted close enough to sense its presence, you might see the accretion disk, a whirlpool of fire and magnetism spiraling into darkness. It would flicker with flares and jets, each eruption casting ripples of light through the nearby stars, illuminating the galaxy's inner sea. Yet for all its brightness, M87 would be strangely silent. In the vacuum between its stars, no sound could travel. The galaxy's glow would be eternal, but wordless, a billion suns shining without a whisper. It's a humbling thought that something so immense, so vibrant, could exist in perfect quiet. And within that silence, you might feel the weight of scale. Each of those trillion suns would host its own worlds, its own histories, perhaps even its own forms of life, each orbiting unaware of the others, flickers of consciousness separated by oceans of light. You would be surrounded by life's potential, yet utterly alone, floating through the greatest cathedral ever built, one made of gravity and starlight. If you looked outward, beyond the galaxy's edge, the view would change. You'd see the rest of the Virgo Cluster, hundreds of galaxies glowing faintly in the distance, each one a swirling congregation of stars. And beyond them, the deeper black, where expansion pulls space apart, carrying the farthest galaxies beyond sight. Even here, within M87's brilliance, you would still be a witness to the universe's great separation, light clinging desperately against the encroaching dark. From within, M87 is both magnificent and melancholic. Its beauty lies in its abundance, in the way it erases emptiness, yet its vastness is a reminder of solitude on an unimaginable scale. You could wander its stellar fields for 1,000 lifetimes and never see the same sky twice, never reach its edge, never find a moment of true darkness. The view from within M87 is the universe turned inward, infinite, glowing, and serene. It's a vision of creation at its grandest, a cosmic ocean of light that humbles everything smaller than it. To exist within it would be to live inside the memory of the universe itself, a place where time slows, silence reigns, and the stars never go out. Though it may seem eternal, even M87 will fade. Its stars will die, its black hole will slowly evaporate, and the galaxy will dissolve into the quiet entropy of space. But for now, it burns. For now, its light still reaches across the cosmos, a billion suns woven together in a shimmering tapestry of gravity and fire. Each photon escaping from M87's heart carries a story written billions of years ago, racing outward into the infinite dark. To look at M87 is to see time itself illuminated, a living ember from the early universe, still glowing fiercely despite the cosmic winds of expansion that stretch and cool everything around it. Every star, every cluster, Every thread of starlight within M87 contributes to this endurance. Its oldest stars have been burning for more than 10 billion years. Their light, the remnant warmth of an earlier cosmos. Around them orbit younger stars, born from the ashes of ancient collisions, continuing the cycle of birth and decay that defines all galaxies. Together, they form a self-sustaining beacon, a balance between creation and destruction that has endured since long before our world existed. And at the galaxy's heart, M87's supermassive black hole acts as both destroyer and preserver. It consumes matter relentlessly, yet its energy output fuels the very processes that keep the galaxy alive. Its jets regulate star formation, its gravity organizes the cluster around it, and its magnetic heart powers phenomena that ripple across tens of thousands of light years. It is the galaxy's paradox, the thing that devours, yet also the thing that sustains. Still, even giants like M87 are not immune to time. The forces that build galaxies are the same ones that eventually undo them. In a few trillion years, its brightest stars will burn out. The great blue and yellow suns that once filled its skies will cool into faint red embers and then into the invisible silence of white dwarfs. The black holes and neutron stars left behind will drift through the void, occasionally merging, releasing their last bursts of energy into the darkness. Over unimaginable spans of time, the galaxy's light will dim. Star formation will cease as gas runs out. The brilliant halo that once glowed with gold will fade to grey. Even the supermassive black hole, the seemingly eternal core of M87, will not last forever. Through a process called Hawking radiation, it will slowly lose energy, evaporating atom by atom over timescales longer than the current age of the universe multiplied by billions. One day, even that heart will wink out, leaving only a whisper in the curvature of space-time where it once was. By then, the universe itself will be a different place. The cosmic expansion will have carried away every other galaxy, stretching their light until it disappears beyond the cosmic horizon. The Virgo Cluster, once a lively city of galaxies, will be reduced to a single, merged colossus, the quiet remains of what was once M87. It will drift alone through a universe grown vast and cold, its stars dim but steady, its energy spent but unforgotten. And yet, even in that distant epoch, there will be echoes of its flame. The light we see today will still be traveling, crossing the void long after the galaxy that created it has faded. That light will wander through space until it, too, is stretched beyond perception, becoming part of the cosmic background. But in that light is history. In it lives everything M87 ever was. Its stars, its collisions, its black hole, its endless cycles of death and rebirth. To us, observing from a fragile world orbiting a modest star, M87 stands as a symbol of endurance, proof that beauty and order can persist even in a universe ruled by decay. Its glow is not eternal, but it is enough. Enough to outlast empires, civilizations, even species. Enough to remind us that impermanence does not mean insignificance. For now, M87 burns. It burns with the fire of creation, with the light of a trillion suns, with the memory of everything that has ever been. And though one day it will fade, the meaning of its light will not. Because in the vast, cold expanse of time, every spark matters. Every flame, no matter how distant, leaves a trace. And so, long after the stars have dimmed and the galaxies have vanished, the light of M87 will continue its journey. A single, enduring flame, carrying with it the whisper of a universe that once was bright. The true size of M87 cannot be captured in miles or light years. It exists in influence, in gravity, in the pull it exerts on everything near it. Its size is the measure of everything it commands. We often try to define things by their boundaries, by where they begin and where they end. Its true extent isn't drawn in light or matter, but in power, in the reach of its gravity and the space it bends to its will. To measure M87 is to measure an idea, not an object. Because how do you quantify something that holds an entire cluster of galaxies in its grip? How do you assign a size to influence that stretches across millions of light years, sculpting the motion of stars, gas, and even time itself? In that sense, M87 is less a galaxy and more a gravitational domain, a region of space-time carved out by its mass and history. Within its reach, thousands of galaxies orbit like planets around a star, each one following invisible pathways dictated by M87's colossal pull. Even light itself must bow, bending as it passes near the galaxy's core, tracing elegant arcs that betray the unseen geometry beneath. It's as if M87 doesn't just exist in the universe. It shapes the space that the universe occupies. Astronomers can describe its size in physical terms: 500,000 light-years across, perhaps 1 million if you include its faintest outskirts. But those numbers feel inadequate, almost meaningless. The scale is so immense that our language collapses under its weight. What matters more than the galaxy's physical edge is its gravitational reach, the zone of control within which its presence defines the motion of everything else. This reach extends far beyond its visible light, past the halos of gas and stars, out into the dark matter that envelops it like a shadow. And it is dark matter, that unseen majority, that truly extends M87's domain. The visible galaxy may be vast, but the invisible one is larger still. The dark halo surrounding M87 could stretch millions of light-years into space, blending imperceptibly into the surrounding Virgo Cluster. Its influence governs the motions of galaxies we can't even see with the naked eye. If light defines what is, gravity defines what matters, and M87's gravity extends nearly without limit. To visualize, it is almost impossible. Imagine a sphere so large that our entire Milky Way, with all its stars and planets, would fit inside it 1,000 times over. Within that sphere, every particle of gas, every star cluster, every drifting remnant of a devoured galaxy feels M87's tug. Even at the cluster's edge, where space begins to stretch and drift away into expansion, that faint gravitational thread still connects back to the giant at its center. And this is where the notion of measuring infinity becomes more than poetic. It becomes literal, for M87's influence, though finite, reaches far enough to blur the boundary between the local and the universal. In the gravitational fabric of the cosmos, there is no sharp divide. Forces fade, but never vanish completely. The galaxy's mass, its energy, its magnetic storms, all radiate into the void, their effects echoing outward in diminishing ripples. Even the light escaping from its stars and jets continues on forever, stretching endlessly through expanding space. When we speak of infinity in astronomy, we often mean distance, the unreachable, the unbounded. But M87 teaches us that infinity is also a matter of connection. The galaxy's true size isn't how far its light travels, but how deeply its existence shapes the things around it. From the smallest particle orbiting near its core to the largest galaxies circling its cluster, everything within its gravitational reach is part of its body, part of its breath. M87 is less a place and more a phenomenon, the embodiment of influence on a cosmic scale. To look at M87, then, is to see the physical expression of infinity made visible. Not because it never ends, but because it contains more than any one definition can hold. Its gravity binds galaxies, its light bridges time, its presence bends the laws of nature themselves, proving that even the universe's wildest extremes can be understood through the same physics that governs the fall of an apple. And perhaps that is the most awe-inspiring truth of all. Infinity doesn't need to be imagined, it's already here. M87's existence is the living proof that the universe does not deal in absolutes or edges, but in continuums, in gradients of power, light, and motion. When scientists measure M87, they are not really measuring a galaxy, they are measuring the reach of creation itself, the scale of gravity's imagination. Its true size lies not in its boundaries, but in its influence, in the way it teaches us that even infinity can have structure, and that even the vast can be understood, not by where it ends, but by how it shapes everything that surrounds it. And yet, for all its power, M87 moves through space with a calm grace, silent, patient, watching. It is not chaos, it is balance. A vast, sleeping God in the fabric of the cosmos. From a distance, you might imagine M87 as a storm, a galaxy of jets, collisions, and gravity tearing space apart. But in truth, it is serene. Every motion within it, from the spin of its stars to the pull of its black hole, is part of a perfect equilibrium. Nothing happens in haste. The galaxy turns once every few 100 million years, a slow and stately rotation that belies the violence of its past. Even the energy erupting from its core, the jet that stretches across space for thousands of light years, flows in rhythm, pulsing gently like the breath of something ancient and alive. This is not stillness born of absence, but of mastery. M87 has reached a state of cosmic peace through balance, the perfect counterpoint between gravity and energy, mass and momentum. Every atom within its colossal body is held in delicate tension, pulled inward by gravity, yet supported by the pressure of its collective motion. The galaxy's outer halo drifts softly through the intergalactic medium, while its heart blazes with unimaginable intensity. From afar, the two seem contradictory, but together they form a single, unified harmony. If we could watch M87 over millions of years, its changes would unfold like the slow rhythm of a heartbeat. Galaxies nearby might orbit closer, stars might merge or fade, and its central black hole might pulse with new energy. But the overall shape, the balance, would remain. It is a living sculpture in motion, one carved by gravity and time, each part moving in coordination with the others. That balance is what makes M87 so enduring. While smaller galaxies twist themselves into spirals and collapse under the weight of their own instability, M87 sits in quiet dominion. It has no arms, no complex pattern of rotation, only the smooth, elliptical glow of stars in perfect distribution. It is, in many ways, the end state of galactic evolution, a form of cosmic maturity. Its stillness does not mean inactivity, though. Beneath that calm surface, energy continues to flow. Magnetic fields twist and realign, stars orbit in graceful ellipses, and dark matter weaves through the galaxy's core like invisible wind. The jet, despite its ferocity, is constant, unwavering, almost meditative in its persistence. It's as if M87 has learned to channel the chaos of its birth into something controlled, deliberate, and eternal. If you could stand on a world deep within M87 and look up, you might sense that balance in your bones. The sky would glow faintly with the light of distant stars, and time itself would feel slower, more deliberate. Every movement, from the orbit of a moon to the flicker of a star, would unfold with infinite patience. There would be no rush, no turbulence, only the endless rhythm of a galaxy that has achieved stillness through power. And this stillness extends beyond the visible. The gravitational influence of M87 reaches out like a soft hand, guiding nearby galaxies into graceful orbits. Even as it dominates the Virgo Cluster, it does not thrash or pull violently. It simply holds, the way a planet holds its moons. Its presence shapes everything around it, yet it does so in silence. There is no sound in space, only motion, and M87's motion is the embodiment of quiet control. In the deeper sense, M87's stillness is not a lack of movement, but a form of cosmic meditation, the equilibrium that comes after eons of struggle. It was once chaos incarnate, collisions, mergers, and explosions shaping its mass. But with time, that turbulence gave way to symmetry. The galaxy is now a monument to what the universe becomes when it learns to balance itself, vast, luminous, and serene. When we look at M87 from Earth, we are seeing not just a galaxy, but the embodiment of cosmic patience. It reminds us that power and peace are not opposites, they are partners. The same gravity that tears apart stars also keeps them in orbit. The same black hole that devours light gives rise to one of the most magnificent jets in the universe. M87 is the universe in repose, not empty but fulfilled. Its stillness is the stillness of understanding, of purpose found after chaos, of balance achieved on scales too vast for the human mind to grasp. It moves, but slowly. It shines, but gently. It exists, but without strain. It is the calm center of a restless cosmos, the heartbeat of infinity, beating so slowly that to us, it feels eternal. And perhaps that's the greatest secret of M87, that true power does not shout. It whispers. It endures. It waits. And so, as we drift away from the heart of Virgo, let us take one last look at Messier 87, the silent monarch of the cosmic deep. For all its immensity, all its power and mystery, M87 is more than just a galaxy. It is a mirror, reflecting back the story of everything the universe has ever been and everything it will become. Within its glow lies the record of creation, the births and deaths of stars, the merging of galaxies, the bending of time, and the patience of gravity itself. It reminds us that even in a universe ruled by impermanence, there is harmony. That light, no matter how faint, no matter how distant, always finds a way to endure. And that the same laws shaping this giant's destiny are the ones that cradle us here, on our small blue world, orbiting an ordinary star. When you think of M87, think of it not as far away, but as connected, part of the same web of gravity, the same flow of energy that binds every atom in your body to the stars above. The same forces that hold that galaxy together hold you together. The same light that crosses 50 million years of space brushes gently against your eyes tonight. So, as you drift into sleep, let your thoughts expand beyond the walls of your room, beyond the Earth, the Sun, and the Milky Way. Imagine floating in the stillness between galaxies, where the light of M87 glows softly in the dark, a beacon of serenity in an infinite sea. Take comfort in the knowledge that you are part of this vast, beautiful system, a fleeting moment within eternity's grand design. Just as stars are born, live, and fade, so too do our moments, each one precious and irreplaceable. And maybe that's the truest wonder of all, that we, tiny as we are, can look up at something so enormous and understand it, that we can give meaning to the light, and in doing so, find a little of that same light within ourselves. So rest now. Let the stars keep their watch. Let the galaxy spin. Good night. Sleep gently. Beneath the quiet glow of Messier 87.